Once
This
you've opened
conference
it,
will now be recorded.
sure. Once you've opened it, just again, maybe you can just unmute yourself and just let me know that you've opened it, or just put it in the chat box that you've opened it, so that I know you've opened it. Okay, Arun, thanks. Arun is the first one. Thank you. Ramina again. Okay. Amal Subramanian. Okay. Manoj, MJ, Kalis. I've got 5 people who opened it already. Okay, Aisha opened. All right, perfect. Jitin, yes. Okay, perfect. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people, 12 people. Srinivas, I've already sent the link. I'm going to paste it again. Here it comes. So I've got 12 people who opened it. Hi Jayashree, welcome. You've just joined. There is a link in the chat box. If you can just click on it and open it, we are good to go. You've not missed anything yet, so no worries. Okay, so I'm also going to, in parallel, share my screen with you guys so that you can see. Let me know if you can see my screen. The Econivas, it's just coming. One second. It's sharing right now. Okay, there you go. Okay, so now you should be able to see my screen. Okay, Vidya, thank you. I got you done. So I hope everybody's been able to open their screen. And now I don't know how this is going to behave on a mobile phone, but our intention from the beginning itself is to introduce you to Econivas in a manner that is applicable for you. It's application based. And through the application, we will address the theory. So again, very quickly, for the demographics, I wanted to understand out of the people who are here right now, how many of you are architects and how many of you are engineers? Can you just quickly just type in the chat box? If you are an engineer, just put in ENGG, and if you're a okay, Jitin, I got you. You're an engineer. I got that. Okay, Jayaprakash is an architect. Okay, uh, Tikendra Kumar is an engineer. Okay, Amal Subramanian engineer, Subramanian engineer, Ramina engineer. Sajid Kumar, Ramesh, EMJ Kalis, Arun is an architect. Sorry, Arjun is an engineer. Shiny Sam is an architect. Manu Mohan is an architect. And there's someone called User who is an engineer. Okay, great. Perfect. So I've got 3 architects so far. And okay, Vidya is an architect. Okay. And I have Dr. M. Thirugnanasambandam. If I misspell your names, please correct me, all right? I would like to get your names right and not mess around with your names. So, is an engineer. Jayashree has arrived. Okay, good, perfect. Now, again, another question. So, I'm just trying to get to know you guys better so that we can do this in as customized a way as possible. Sorry, Mithun, you unmuted yourself. You want to say something? Okay, Mithun has muted himself. Okay, so how many of you have had an opportunity of already having worked with ECBC or IGBC or Griha or Econivas Sanhita for that matter? Is there anyone who's already worked on these systems? If you have, please type in the chat box what system you worked on already. Okay, MJ, I got that. No. What about the others? Have you already worked? Okay, Dr. M has said no. Ramina has said no. Vidya, no, sir. You can call me Gaurav. No. Uh, okay, Tikendra has said no. Okay, Mithun has said no. Jayaprakash, no. Okay, okay. Subramanian CV, no. Jitin, no. Yes, okay, I've got Basil. Okay, excellent. Basil has said yes. IGBC, that's great. Aisha, no. Okay, Dr. M, I got you. Sambandham in short. Okay, that's great. Thank you. Thank you for uh, letting me know that.
Sir, I'm mechanically there, sir.
Hello, sir. Gaurav, sir. I think he's offline.
Hello, am I audible now? Can you hear me now?
Yes, sir. Now you are audible.
Okay, great, perfect. I have to go into settings and change a small setting. And yeah, okay, perfect, awesome. Thank you for pointing that out. Whoever that was, thank you very much for pointing that out. Otherwise, we would have just gone on and on without any sound. Okay, so what I was basically saying was that Econivas is a very simple tool. It is designed to put the power into the hands of the common people. We guys have spent a very long time, more than a decade and a half, on simulation software and computer simulations that has a very steep learning curve, especially when you start getting into making mistakes and trying to figure out what is the reason why you made that mistake. So Econivas for one is a system that allows you to do that with a tool and without a tool. You can do it manually also, just using a software as simple as Excel and get your results. You can do it using a software tool as well. So for starters, I will take you through a very simple but very interactive tool. There is something called the ENS Compliance Tool, which if you click on, then it will open this window. Sorry, wait, don't go to the ENS compliance tool once again. Yeah, go to the analytical tool. Sorry, you'll have to download the ENS compliance tool. Just go to the analytical tool. It'll open this window, and we'll start learning all that there is to learn about how to make a Econivas compatible building by using this analytical tool. This will also give you a feel for what kind of numbers are we talking about, what kind of energy saving can happen, so on and so forth. So one of the things that you need to keep in mind is that the Econivas is for building plots that are greater than 500 square meters, right? So if the plot area is greater than 500 square meters, it needs to be Econivas compatible. If it's less than that, then it's not necessary. Then it becomes something that if you want to do, it's great to do because it's just really good for, it makes energy sense. Now, when you arrive at this landing page, we'll start with something called the basic tool, and we'll learn about Econivas through the basic tool. So you just need to click on the image of the basic tool and it's going to take you to the basic tool. It'll start with this pop-up, right? Now, we'll go screen by screen. We'll have fun in the process while doing this. You guys can very easily learn how to do a quick analysis, by playing with a graphic user interface, and and also we'll clarify whatever doubts you need to have. So there is one request that I have from all of you. Because I am working in this field, it has been a long time. There are times that I will say things that I will take for granted that you will know. Now, that's not necessary. So, my request is you need to stop me immediately. Do not wait for later. Don't think that this might be a very silly question. Please just feel free to immediately stop me. If you need to unmute, just unmute and stop and say, Gaurav, you need to repeat that. I did not understand that. Or what word did you use? What term did you use? How is it relevant to me? How does it work in the real world? This is sounding too theoretical. What will it mean in practicality? Any such question that comes up for you, please ask me immediately. Do not keep it for later, right? So Subramanian has asked how to get the analytical tool. So I am just going to go back to the Econivas main page. This is the Econivas main page. So everyone, you can just follow what I'm saying. You need to go to Econivas, the tab on top. If you see, it starts with home, about us, star label, Econivas, right? So when you click on Econivas, you will get these three options, and the topmost is called Analytical Tool. And then you've got a ENS Compliance Tool, and then you also have a tutorial video that teaches you how to use the tools. Now, has everybody come to the Analytical Tool page? So everyone quickly give me a yes if you've reached the Analytical Tool page. What I will also do is to paste the link of the tools into the chat box. You can directly click on this and open it. Okay, I got that. Thompson, Manoj, Basil, Amal, Subramanian. Arey Baba, I am not sir. My name is Gaurav. I have not been knighted. Jay Prakash, thank you. Vidya, okay, I got that. Aisha, yes, perfect. That's great. That's great. All right. So once you've come to the analytical tool page, like I said, very simple. Just click on the basic tool picture. If you click on the basic tool image, it will immediately open. This splash screen is going to open first, and it's going to ask you select state, right? And this is our map of India with the 5 climatic zones. Terrible simplification of India's climate. India has more than 155 soil types. Oh. India has more than, am I audible?
Yes, yes, you're audible.
Okay, great, perfect. Thanks, President. So India has more than 155 soil types. Kerala itself has many different soil types. If you look at the soil type map of Kerala, you'll see at least 25, 30, maybe even more soil types. And as we know, soil changes with climate. So climate varies drastically, but as per the National Building Code and the Energy Conservation Building Code map of India, they've divided India into 5 climatic zones. Earlier, you might be aware, it used to be 6 climatic zones. Then they clubbed cold and cloudy and cold and sunny into one climatic zone, which is cold. So now we've got 5 climatic zones. So let's begin by selecting our state. We will select Kerala. And then when you click on city, then unfortunately they only give you the option of 2 cities. So this again is a gross generalization, primarily because if you go to a place like let's say Kodamangalam, or if you go to inland from Kozhikode, if you go in towards what is that place? If you the Edical, where the caves are, right? Wayanad and all, yeah, exactly. So then the climate becomes very, very different. It doesn't fall under the tropical climate at all. But Kochi and Trivandrum are two cities for which we have climate data that has been logged for some time. So they give you the option of Kochi and Trivandrum, both of which incidentally are coastal cities. So not very representative of the inland mountain climate, the hills climate of Kerala. In this case, I am going to start with Trivandrum. Let's just take the hometown of EMC, and I press continue. So again, when I click on continue, then I will get these three options. What kind of a building are you building? All right. So are you building a building that is standalone? Now, mostly I've seen, at least walking down the streets of Trivandrum, people tend to build standalone buildings. But if you go to Kochi and if you go to especially the slightly denser built areas of Kochi, you might find houses that are built two sides open, which means the back side will be open, the front side will be open, but from the side they'll be touching the neighboring houses. You could also have a three-side open house, which means that it's touching a building on one side only. So in this case, what I'm going to do is I'm going to take the most prevalent typology that I've seen in Kerala, and you can correct me if I'm wrong. The one which is standalone, which means that it is open from all sides. It's got a narrow passage on all sides, or it might have a big front lawn and a back lawn, depending on how much area people have, right? So we can start with standalone. Now, once you take a standalone building, you can mention the area per floor, and you need to select what is the orientation that your building faces. Now, when they are talking about orientation, we are talking about the front dominant face of the building. What side is it facing? What is the orientation of the building? So, what is the area per floor that you would like to work with? So, let's say if we have a 500 square meter plot and we have, let's say, 30% ground coverage. Right now, I hope that at least these terms are very comfortable. People are comfortable with people like ground coverage, floor area ratio. You can stop me if you're not familiar with these terms. But if the plot area, let's take the plot area to be 1,000 square meters, which is a pretty large plot, but just for ease of calculation, and we can take ground coverage 30%, so the built up area is 300 square meters. And we can say that the per floor area itself is 300 square meters. So we can put 300 over here. And then it's asking me what orientation is it facing. Now this is obviously a simple tool. Is it facing north, south, east or west? If it's slightly tilted in a few different directions, then that kind of detail you might not be able to go into this tool with. So we'll just do a simple calculations. Let's say we take a north facing building and then we say continue. So far, are you with me and have you reached this screen? If not, I will repeat myself. And please don't hesitate and ask me to repeat myself as many times as you want. Okay, because this is your program. It is for you to learn. Basil has asked, what is the building area? I have taken 300 square meters per floor. We will come to the building area right now because it is going to ask you how many floors, what is the total area to calculate the EPI, right? So right now I've just taken area per floor as 300 and you can put that down. Anyone else, any other questions or queries that you might have?
Hello.
Yes.
Automatically calculate taken as 1200 building area.
Okay,
The
so that means
previous window.
in the previous window, okay. Got it. See, because over here I'm only looking at 300 square meters, but that means it is assumed that the building has 4 floors, which means that it's a stock typology that you will come across in Delhi, which is stilt plus 4. right? Or it's just assuming that it has 4 floors. Thanks for pointing that out. I was not aware of that. So this is a north facing building, all right? Now, if you look at the left side, it shows you select energy efficiency measures, all right? And it's got a whole host of energy efficiency measures. Now, this will require a certain amount of background knowledge, but not too much, of how do buildings function? What is the premises of heat transfer, okay? Now, in this case, mostly it's very easy to understand how heat transfer happens in buildings because you are familiar with that process yourself. Now, what does that mean? I'll explain myself. You stand under the sun the way you should make your building stand under the sun. What does that mean? When you are standing under the sun, you never stand facing the sun with your eyes wide open. You don't do that. You always make sure that you're standing with your body facing away from the sun. If you're talking to somebody, you will make sure that they stand in a place where the sun is on the side and you are facing them and talking to them like this so that you do not experience direct sunlight in your eyes. So what you do all the time is that you correct your orientation. You do it on a minute to minute basis or maybe on a 5-10 minute time scale to adjust how you stand in the sun. Now, if you cannot adjust how you stand in the sun, when are the times that you cannot adjust when you're standing in the sun? You can't adjust your position. So you have to do something else. Can you give me an example, any of you, when you are fixed in position and you cannot adjust your orientation? What do you do? Number one, what is the condition? When is it that you experience that you cannot change your orientation? Okay, superb. So Jitin has said share. So I forgot. Just a moment. Yeah, Dr. Sambandam has asked a question. Dr. Sambandam, I'll come to this question. I will come to that. So Dr. Sambandam did something very interesting. He clicked on the best combination, so he got the best possible result. But we want to try and understand the process a little better so that you can go into slightly more advanced calculations as well, right? And we'll come to that aspect a little later. So Jitin has said shade, okay. Subramanian has said wear a cap. Basil has said walking using an umbrella, very good. Sajid has said shade. Dr. Sambandam has said thank you. Yes, you're welcome. I will make sure that I answer your question. Absolutely correct. When you are standing in a position where you cannot change your orientation, you will do something very simple. You will use your hands. You will use a notebook that you're holding in your hand. You will wear a cap. If you're luckily carrying an umbrella, you will open the umbrella. What if you don't have any of these things? Now, a common experience that you would have had is when you're traveling in your cars. You're traveling in your car and you're driving on a road which is facing the sun. In that case, what do? You do some very advanced calculations, which your mind does on its own, and you adjust the shade of the car so that it cuts the sun that's coming in your eyes. So many of you would have noticed you are driving in the car or you're seeing somebody who's driving in the car. They have adjusted the shade of the car in such a manner that the sun gets cut over here. So there'll be sunshine that is falling over here, but this portion will be shaded. That means you have performed some super accurate calculation and you have made sure that your eyes get shaded from direct solar radiation so that you can drive comfortably. Otherwise, of course, it's a hazard. You've experienced all of this you have experienced, right? So you will always do adjusting of orientation first. If you cannot adjust orientation or your orientation is fixed in a certain place, you are going to work on two aspects, shading and window to wall ratio. Now, I want you to note these terms down. I'm going to put them into the chat box just for your reference. There is shading and there is WWR or window to wall ratio. What do you do to adjust your window to wall ratio? So first and foremost, where are your windows? Everybody has heard this phrase in English. Put a phrase in the chat box, an idiom in the chat box. Eyes are the windows of the soul. You have all heard this phrase, right? So your eyes are your windows. Now, when I say that you're standing in the sun, you can't shade yourself and you can't change your orientation, you automatically modify your window to wall ratio. What do you do? Someone use the chat box and tell me, what do you do? How do you as human beings? Absolutely, yeah, Jitin. So I'm going to modify that. You don't close your eyes, you squint your eyes. You do this. You squint your eyes. Now, what is squinting the eyes? Squinting eyes is to use the aperture of your eyes to control the amount of light that's coming into your eyes. Because even your lens, your pupil, which is contracting and dilating, reaches a threshold beyond which it can't control the amount of light that's coming in. So then your eyelids have to control how much they open or close. So you engineers and architects are masters of energy efficiency and green design. Masters. You have lifelong experience. You have been doing this ever since you were children. Just that you didn't realize that the buildings are nothing but extensions of your skin. Very correct. Mithun has said something very interesting. Is it the same for places with strong winter climate, less sunshine during 4 months? So strong winter climate places might function slightly differently. Strong winter climate places would depend largely on what is the sunshine condition over there. So you might be familiar, those of you who have traveled to very cold places where it snows, you will see that the local people will have facial features such as what we call mongoloid features, which many times is considered to be a derogatory term, but actually it is the features of the people itself that allows for less light to come in, especially in glare conditions. So it is not only us that experience glare, but even people who are in very cold climates will experience glare, which is why when you go to places that snow, many times people will tell you that you should be wearing goggles. Am I audible? It
Yes, sir,
seems
you
like
are
my
audible.
video, okay, it seems like my video is frozen. Okay, so I'm just requesting the EMC team to just, in case you see my video fluctuate or audio fluctuate, just let me know immediately. I have WhatsApp open in front of me, so I can take a look. Okay, now, just a moment. Yes, okay, video is back. Okay. Great. So, like I said, you are very familiar with this process. You do it all the time. As a matter of fact, you go one step ahead. You not only modify the way you stand and the way you face the sun and how you orient yourself and how you shade your eyes, you also control the next thing that Econivas Sanhita talks about, which is envelope based heat transfer. Envelope, this is my envelope, this is my envelope, this is my second skin, and as soon as I talk about buildings, they become my third skin. So what do you do in Kerala if you're from the hotter, more humid parts? What do you do to control the heat using your clothes? So someone use the chat box and tell me, what do you do? You can think about fabric, you can think about color, you can think about the actual type of clothing. What is it that people do? Okay, Sajid has said absolutely use cotton fabric, light cotton fabric. Ruby has said use light cotton fabric, and half sleeve cotton shirts. Mithun has said half sleeve cotton shirts, white, light colored. Absolutely, Jitin has said light colored. That's wonderful. This is absolutely perfect. So you are talking about reflecting the light of the sun because you're wearing light colors. Number two, whatever breathability your skin needs in terms of letting the sweat evaporate will happen through light cotton fabric, right? And cotton itself will have the ability of absorbing the sweat, which synthetic will not do. Like in North India, the local people say synthetic will keep itself clean, but your body will stay dirty. But cotton will clean your body and itself will get dirty. That's a local phrase that people say in North India, right? So you will use light color, you will lose. Now, half sleeve shirts, very important to understand that most people who work under the sun, for example, farmers who are working on open plots of land will never use half sleeve shirts. You will find most local people in farming communities will wear full sleeve shirts. They'll not use half sleeve shirt. Why would they not use half sleeve shirt? Why would they use full sleeve shirt? And obviously, I'm not talking about people who are working in tree plantations and rubber plantations because there you are shaded by the trees, like maybe if you're in a banana plantation. But if you are working with a crop, then people will wear a full sleeve shirt. Why would they do that? Why would they not wear half sleeve shirts? To protect from the sun, absolutely, Mithun, very correct. You want to protect your skin from the sun as much as possible, and also the harsh solar radiation when the sun goes straight up, then it becomes very harsh. So you'll also see very naturally that most people who are into farming will get up, will go to the farms much before sunrise. By the time sun rises, their work is already done. And then they'll come inside, they'll have their breakfast, and they'll rest. Then again, early evening, they'll go back onto the farm. So what we practice on an everyday basis is very important to understand from a building energy saving perspective. Because everything that we do which is in harmony with nature, we can extend it to our buildings as well. It becomes very easy to make a energy efficient, eco-friendly building. All right. Any doubts so far? Any questions? Clear. Okay, great. Jayaprakash has said clear. Okay, I've got Nasreen has arrived. I see Azim has arrived. I've got a few more people. Ramesh has come. Welcome, guys. You've not missed too much, just a little bit, but make sure that this link is open in front of you, what I'm sharing on the screen right now, which is the Econivas tool. Econivas.com is the website that I'm on right now. Okay. Now let's start playing with the energy efficiency measures that are listed on the side, and let's see how much does each intervention impact the building. Okay, so let's start with the roof. Now, what do people do for the roof? In hot climates, they'll tie a cotton towel around their head while they're working in the fields. Traditionally, regardless of whether it was South India or North India, people used to wear turbans, which would insulate the roof. That we call it roof insulation, right? And traditionally in clothing, we would wear turbans, right? So what are we going to do? We're going to first open the roof dialog and see whether you want to go for an efficient roof or a highly efficient roof. Now, in my experience, I have personally worked on maybe more than 150 green projects so far, including Griha, IGBC, etc. Just give me a moment. Got it, got it. Thank you, Vijayan, KK Vijayan. Thank you very much for your message. So, in my experience, 50 mm is less and 100 mm is too much. So, we have never worked in a building where we do either 50 mm insulation or 100 mm insulation. We normally do 75, which is basically 3 inches, right? So, in this case, you can start with an efficient roof, which is 50 mm insulation. So, as soon as you click on 50 mm. So you need to drag and drop it onto your building. So you need to grab it, bring it to your screen. I hope you can see this, and drop it on your screen. You'll see that the color of the building changes and you will see that your energy saving has started. So from the baseline, which is standing at somewhere around 160 kilowatt hour per square meter per year in terms of EPI, it has come down to a little less than 150. Now, I want to ask all of you a question, and this is going to be very interesting for the architects and for the engineers equally. How many of you have access to your electricity bills right now? Yes, Dr. Sambandhan has asked a question and I want to address it. Insulation, it's over and above the plaster. Yes, so mostly what we do in hot climates, very important to, this question is very important for everyone. Thank you for asking that question. For hot climates, we do something that I'm putting in the chat box. It's called over deck insulation. Over deck insulation is always above the roof slab, right? So you're going to do the insulation up. So you're going to have the plaster underneath, you're going to have the concrete slab. Then you will have something that is laid to slope. So maybe it could be brickbat, Koba, or whatever it is that's laid to slope. Then you're going to have some sort of a filler layer. Then you're going to have your insulation on top of that. Then you'll have maybe a little thin layer of mortar or screed. And then you can put your mosaic tiles or your regular roof tiles on your roof as the final finish, right? And obviously below that, on top of the roof slab, you will have your waterproofing treatment. So those of you who have familiarity with construction processes, mostly in hot climates, we will always do insulation above. Now there is a new challenge that comes up, which is you cannot do soft insulations on the roof. You have to do hard insulations. You have to do bats. You have to do things like XPS, extruded expansed polystyrene, which can take the load of people while walking on it and doesn't get punctured, right? Anything soft like glass wool will get compressed and it's going to lose its ability to insulate the building. All right. Yes, excellent. So Dr. Sambandhan has asked 50 of what material? So like I mentioned, outside, like I said, over deck insulation is outside. Over deck, again, I just assume that everybody understands over deck. I'm sorry about that. Over deck basically means that the insulation needs to be outside, which means on top of the roof slab. So this is the inside of your building. This is the roof. It's going to be on top of the roof slab. Now, why would I put insulation on top of the roof slab? Someone tell me, why would I put insulation outside? Why would I not put insulation inside? By the way, you can put insulation inside. Why am I putting insulation outside and not inside? Somebody give it a guess. Have fun, guys. There is no right or wrong answer over here. This is not a test. This is life. We learn through experimentation. So can anyone give it a guess? Why would you do insulation on the outside? Why would you not do insulation on the inside? Okay, Subramanian has said prevent radiation heat entering. Insulation outside prevents heat to enter the building. Absolutely. You get the max sun incidence on top. Okay, very good. One is that you get maximum incident solar radiation on top. Second is you want to cut the insulation, the incident radiation and the heat transfer due to temperature difference on the outside itself. Because what happens otherwise is that you've got your roof slab. The roof slab is going to absorb all the heat of the direct incident radiation. It's going to absorb that heat and retain it in its thermal mass. And then you have insulation below. So it's preventing the contact conduction based heat transfer to come through into your building. Whereas if I put it on the outside, it's cutting that heat absorption itself on the outside. Now here's the interesting part. So Dr. Sambandhan has said it again depends on cold or hot insulation. Okay, I'm not very familiar with that term. Mostly, again, like I said, I'm speaking very specifically about hot climates, not cold climates. Like I started off in the beginning, in hot climates, we do overdeck insulation. In cold climates, we don't do overdeck insulation. So we've done a pretty large project. It's about 180,000 square meters of a school in Bhutan. Now, if you take a place like Bhutan, where the maximum temperature goes 28 degrees Celsius, but minimum temperature goes down to minus 15, then all the insulation happens inside the building and not outside the building. It doesn't make any sense to do insulation on the outside. Dr. Samandan has also said air-conditioned space and non-air-conditioned space. That doesn't make much of a difference. We must remember one thing, and obviously this is for everybody's information. We want to utilize the impact of thermal mass. If you put insulation on the outside and you air condition the inner spaces, then all the thermal mass is on the inside of the building, which means that if I'm using air conditioning, regardless for heating or for cooling, the thermal mass can absorb the heat or can contain the cold for a longer period of time. Very simple. It's called thermal lag. If you look at the National Building Code, Part 8, Section 1, or if you look at codes like SP41, or if you look at the Econavas Sanhita book or the Ecbc design guide, then all of them will tell you that thermal mass preferably should be on the inside and not on the outside. Again, if I do insulation on the inside, of course that makes sense if I'm in a very cold climate, because there is also radiant heat transfer between the human beings and the envelope. I will explain what that means to you. Some of you may not be familiar with that term. Very simple example. This happens all the time, especially in a climate like Delhi. If you go to the toilet in the morning when it's very, very cold, then you hesitate to sit on the pot, or you are scared of your skin, of your body touching the walls of the bathroom because they feel very cold. Now, when we say we are feeling cold, actually we are not feeling cold. That is incorrect. Scientifically, that is not correct. Why is it not correct? Because heat flows from high temperature to low temperature. Water flows from high pressure to low pressure. Money flows from rich people to poor people. Energy always flows from high density to lower density. You need to remember that, right? So heat flows. Actually, when we are saying we are feeling cold, we are not feeling cold. We are losing heat. We are losing heat at a very rapid pace, at a very high speed, right? And your building envelope can be designed in such a manner like you design your clothes. The more insulating material you use, the less conductive material you use, the more comfortable you're going to be standing in the sun, the more comfortable your building is going to be standing in the sun. So what did we do over here? So we've saved 9% energy with respect to the EPI. Now, why I asked everybody for your electricity bills is very important. How many of you have been able to find your electricity bills, your home electricity bills? Anyone who has found their home electricity bills? Yes, Jitin, thank you so much for letting me know. Okay, Ramina has said I can, so he or she, Ramina is, I can't tell, has access, which means that they can share it with us. Jayaprakash has said me too. That's brilliant. That's great. So if you have access to your bills, can you just get it? Can you just keep it open in front of you and tell me what is your connected load? So tell me, what is the connected load or the sanctioned load of your residence? 4 kilowatts. So Jayaprakash has said 4 kilowatts. Jitin has said 8 kilowatts. Manu Mohan has said 7 kilowatts. Wonderful. This is absolutely perfect. Now, I don't know if this provision is there in your electricity bills. It is there in the electricity bills in Delhi. If you turn the electricity bill around, you will see past 6 months history. Is it visible in your bill as well? Can you see the summary of the past 6 months? Okay, Manu has said no. We can't see the summary. Okay. Okay, Subramanian has said 10 kilowatt. Jitin also has said no. Okay. Manu has very kindly turned his camera on and he's showing us the bill. So it's a long linear format bill. Perfect. That's great. That's great, Manu. And Manu, tell me, Subramanian is saying we cannot see. You'll have to, I think, pin Manu to your screen. Let me just try that once again. Yes, if you pin Manu to your screen, he's going to occupy a larger portion of the screen. Manu, can you again bring your bill close to the camera? Yeah, there you go. That's the entire bill. You can see it quite clearly with the dates and everything. So, like Manu said, okay, Subramaniam has said we have to go to the site. Thanks, Manu. Thank you very much for showing us the bill. Okay, and Manu also mentioned that the connected load was 7 kilowatts. Okay. Now, here's my question to you. And Manu, you can see your bill. What was your monthly energy consumption? In the last month, what was your energy consumption? And obviously, we are aware that this is not the hottest period or the most humid period in Kerala. So this will not be one of the most energy intensive months. But Manu, can you also see what is the kilowatt hour, what is the unit consumption for your residence? So Subramanian has said we have to go to the site. Subramanian, I want to ask you, can you go to the site and see what is your history? If you can see it, that would be great. I wanted to show you something which is very important for us to understand. So Subramanian has said 256, okay, and earlier he had said that the connected load was 10 kilowatts. Perfect, perfect. Ramina has said, okay, Jitin has said 158, Ramina has said 598. I'm just making a quick note. 598. Jitin has said 158. And Manu has said 452 units. Perfect. Excellent. Thank you. Thank you, people. Now, what Econeva Samhita talks about is the EPI, or the Energy Performance Index, which basically is what is the energy consumption of your building per square meter per year. Okay. So let's say if we take Ramina's, or if we take Manu's case, 450 units in the last month. Manu, do you have any idea what is the area of your house? The total area of the unit that you're occupying in square meters, 120, 150, 2000, sorry, 200. What is the area of the flat that you're living in, or the house that you're living in? Okay, Manu, thanks. I got that. 280 square meters. Okay. Now, here's what you need to do. I hope you're all familiar with the term EPI, or Energy Performance Index. It's very simple. You take 452. I'm giving you a very rough calculation. Actually, you have to do this in real life or through a computer software. I'm going to take 452, multiply it into 12 months. All right. So I'm going to get, what do I get? 12 to 4 carry 2, 12, 5, 62 carry 6, 12, 4, 48 plus 6, 4, 4. So I've got, what did I do? 6, 12, 4s are 48 plus 6, 54. So I got 5424. Right? I got 5424 kilowatt hour per year. Now I'm going to divide 5424 by the number of, okay, Manu, I said this is a 2-month bill. Okay, great, perfect, thanks. So that means it's 452 into 6. Let's round it off to 500 units, okay? So it'll just make our life easier. 500 units into 6, so it's very straightforward. I've got 3000 units per annum that Manu's house consumes. Is everybody with me so far? You need to stop me as soon as you feel that I'm going too fast or it's getting too confusing. Okay? Ranjit Roy has left, which means something happened. So anybody, before you leave, please tell me that you're getting confused. Perfect. This is great. Okay, so let's bring up an Excel sheet or a calculator and calculate what does it come to. So I'm just opening a random rough Excel sheet if I can find one. Yeah. So I've opened an Excel sheet and I'm just doing a calculation. 3000 divided by what Manu just said, 280. And tell me what the answer is. So what did we do? We did 3000 divided by 280. What is the answer? What answer did you get? And you can do this for your own houses, people. All of you, I would encourage you to do it for your own house to understand something. So Subramanian, very simply, Subramanian was calculating for Manu, so he's got the answer. It's 10.714 kilowatt hour per square meter per year. Perfect, 10.71, right? And can someone else quickly do a calculation for their own house? I want you to do a rough calculation. Don't get into details. Like for example, Ramina had said 598. So let's say about 600. So let's do one for Ramina as well. Ramina, can you tell me what is the area of your house? So we've got 600 into, is that also a 2-month bill? I'm guessing KSEB gives 2-month bills. So 600 again would be into 6. So we get 0036. We get 3600. Ramina lives in a 2000 square foot house, right? So I'll have to convert that into square meters. So I'm going to divide it by 10.76. 2000 divided by 10.76, and I get 185.87 or 186 square meters. All right. So in Ramina's case, I'm going to do equal to 3600 divided by 186, and the answer that I get is 19. So I got 11 kilowatt hour per meter square per year in the case of Manu, and in Ramina's case we got 19 kilowatt hour per meter square per year as the EPI, or the Energy Performance Index. Now I hope you can see the ENS, the Econivas Sanhita screen as full screen. Do you guys have it maximized on your monitors? Yes, I've got KK Vijayan asking a very interesting question. This energy index will only apply or useful where ACs are in use, right? So in most cases, the interesting part is that Econivas Sanhita is not only applicable to buildings that are air conditioned, because ENS talks about something called the window to floor area ratio openable, which means that the windows are openable for natural ventilation. Right? And of course, ceiling fans are allowed and so on and so forth. So why I am asking you to do this exercise, very important for you to understand that a lot of times these tools are trying to teach us something that may not be relevant to us at all. I want you to take this with a pinch of salt. When your house is at 19 kilowatt hour per square meter per annum. So I'm going to first do something and then I will ask you to reset to baseline. So let's do what Dr. Sambandhan did right at the beginning. Go to best contribution and best combination and click on it. You see the bottom left side, there's something called best combination with a question mark in green. Click on it and see what is the answer that you get. I'm going to click on best combination. What did you get when you clicked on best combination, which means best roof, best wall insulation, window sizes are best, window type is best, shading is excellent, air conditioner is 5-star, natural ventilation is on, which means your building can be naturally ventilated. What did you get? I am getting an EPI value of around, this would be about 62.5. So around 55. I'm getting a value of around 55 kilowatt hour per square meter per year. So it's in time steps, it's in steps of 15. So half of 15 is going to be 7.5. So 62.5. So it's less than 62.5, which means that I'm getting a EPI of about 55, 56, 57 kilowatt hour per square meter per annum. Can everybody see this on their screens? Give me a yes if you can see this. You clicked on best combination and you got the EPI. Manu, thanks. You got a yes. I got a yes from Manu. Everybody else, please tell me. Okay, Sajid. Okay, yes, around 52. Jayaprakash, yeah, that would be accurate. Okay, Amal, yes, yes. Ramesh, yes. Basil, yes. Subramanian, yes, got it. Perfect. Now imagine that you've got Manu and you've got Ramina's case. What should I do? Should I ask Manu to increase his EPI by 4 times? That doesn't make sense. Because in many cases, the natural EPI of the houses and the dwellings that we are living in are already very low. I have students, I also teach at the School of Planning and Architecture in Delhi. We've been doing online classes. I teach my students how to read their electricity bills. There are students who are living in small towns in India whose EPI is 1.5 kilowatt hour per square meter per year. So what do I tell them? Do I tell them that they're wrong? Their houses are not right. They should be at least in the 50-52 range, which means that they should increase their energy consumption by 50 times so that they are the best building in Econivas. Don't worry, I will still teach you the system, but I'm also letting you know that the system is not flawless. There are flaws within the system as well. How would you rate a building like that? All right. So going back to learning the tool, go to the bottom left corner on your screen and click reset to baseline. And as soon as you do that, the slider is going to go back and attach itself to about 162, 163 kilowatt hour per square meter per year in EPI. Okay. And then pick up your efficient roof again and drag and drop it onto your building. And the roof will get insulated entirely and you will be in a good place because you're saving 9% energy with respect to the benchmark EPI. Now you can unclick roof and go to wall. Now again in the wall you'll see three options. You've got the AAC blocks with plaster. You've got more efficient wall which is brick with 50 insulation. And then you've got highly efficient wall which is brick with 100 insulation. Now, remember, mostly what we do is, again, same rule applies. You cannot leave insulation exposed, neither on the outside nor on the inside. Outside you can. We have done buildings where we have done grit wash. I hope you're familiar with what grit wash is. You clad the building with the insulation, then you put a wire mesh on the insulation and you mix grit into the plaster and apply it onto the building to give it a rough surface finish, grit finish. Now that is possible. If you make a frame on the outer surface of the building, you can also do dry cladding, which is like stone cladding on the building. We did that in IIT Delhi Sonipat complex. We did dry cladding on the building over a layer of insulation. So the insulation was on the outside. If this is the wall, this is the inside space. Outside insulation with stone, dry stone cladding on the outside. That is also possible, right? In a place like Kerala, you also have issues with respect to moisture and rains, which is why one of the best things that you can do in buildings in Kerala is what the local people already do. Now, here's what needs to be understood. Many times when we talk about green and we say we'll tell you how to do a green building, we are not looking at what the local people are already doing. So can someone tell me at the level of the roof, what do people in Kerala do such that it makes their building perform more efficiently thermally? What do people in Kerala do with respect to their roof? Can someone tell me? Jayaprakash has written metal roofing. Very correct. They have a sheet that they put on top of their roof which serves two purposes. GI roofing, Manu has written GI roofing. Excellent. Now, what does that do? That serves two purposes. One, it protects the roof from the rain. So moisture, your seepage problems, standing water, no issues. It's going to get washed off by the sheet that you do on top of your roofs. Second, it makes that space usable. Even during the hot season, it keeps it a little cool. Third, the floor that is your top floor of the building will always be relatively cooler as compared to a building which is completely exposed to the sun. Right? And that is not an option that is shown here. And then, of course, Subramaniam has said tiling. Very correct. Tiling is something that we do anyways, right? So what are you doing? You are creating a shade on your roof and you are doing tiling, which again increases the emissivity of the roof. It reflects the radiation, whether it is short wave or long wave radiation. It reflects it. It doesn't absorb it into the building itself. And then of course, if you have below the tile, if you have insulation, then you have no problems as far as the top floor of the building is concerned. Excellent. So you guys are anyways masters of Econivas and green buildings. And yes, absolutely. So I've got a comment from KK Vijayan. saying solar panels on apartment roofs help both ways. Very correct. Much more expensive option, of course, as compared to GI roofing. And then it will give you a certain payback in terms of the electricity that it generates as well. But mostly to cater to the waterproofing part, you will need to do something below the photovoltaics. Either you'll create a structure or create a GI sheet and then put the panels on it, or you will need to seal the panels with silicone so that water doesn't seep through, so that it acts like a proper waterproof shade as well. Now I also have Jitin saying you can use high SRI paint. So I'm just letting you know I am mostly not in favor of high SRI paint. High SRI paint has a life, mostly lasts about 3 to 5 years. If you've seen it, you would know that high SRI paint starts chipping. It starts thermal expansion and contraction, it starts cracking. Then you have to apply a coat of paint again. Very simple solution in comparison to high SRI paint at 2 rupees per square foot is what is written in our national code SP 41 1987. After the rainy season is finished, please apply 1 coat of tuna. So I hope you know what tuna is. It's hydrated slake lime or lime wash like we used to do earlier in our house. You can mix it with a adhesive like Fevicol, which increases its adhesion, and then you apply it on the roof, and it increases the reflection coefficient of your roof. So it impacts what we call the albedo or the SRI, solar reflective index, and it can be done at a much cheaper cost. Of course, because it can be done at a very cheap cost, you will not see any advertisements and you will not see any companies selling it. Companies will sell what makes things most profitable for them. But for the common people, for residences, what you already do in terms of shading the roof, and then either doing a tiled roof or doing a simple lime wash on the roof also works. In fact, it is written in our national codes. Great. So in this case, what are we going to do? We can pick up the efficient wall, AAC block plus plaster, drag it and drop it onto the building, and let's see what happens. So I've got a total 22% saving if I look at the by adding the AAC wall. And if I do a more efficient wall, then I get a little more saving, 25%. If I do a highly efficient wall, then I get a 27% saving. Now, one more thing that I can do is reset. So I'm just playing with the tool so that you can get a feel for it. I can reset to baseline all over again. And instead of going to the roof, first go to the wall and pick up the highly efficient wall and put it there. And you will see that there is a 18% saving from the benchmark EPI if I don't treat the roof, but I only treat the walls. So out of that 27%, 18% is attributed to the walls and the remaining 9% is attributed to the roof. Am I making sense? Is everyone with me so far? Did you understand what I just did? Did everyone get what I just did? I reset to baseline. I remove my roof insulation. Thank you. Thank you. Ruby, thanks. Subramaniam, Ramina, Sajid Kumar, thanks. Thank you. So what did I do? I just removed the roof insulation. I added the most efficient wall to see how much impact does the wall have. And I saw that I get 18% saving in the wall. So I can do a more efficient case wall or a AAC block wall and I'll get a 12% saving. If I only do wall insulation and roof, I can do a simple efficient roof and I get a 22% saving. So 10% happens just because of the basic roof. Then we go to something called window types. Now, do you want medium windows or do you want small windows? So let's drag and drop and see what is the impact of medium or small. If I put medium windows, then I get an energy saving in addition of 33%. If I remove the windows, my saving was at 22%. So I get an additional 11% saving by doing medium windows. And if I do small windows, let me drag and drop small windows. Then I get a 40%, which means that I got from 22 to 40. I've got a 18% additional saving by using small windows and not very big windows. Now, there is a problem with this. And that problem is that in this case, the building is being shown as absolutely standalone. No, normally that doesn't happen. Normally you will have a neighbor's house to the left, a neighbor's house to the right, maybe some trees in front, maybe some really good trees, or maybe a plantation at the back. Kerala has these beautiful houses, especially in suburban areas where people will have their own trees growing in the backyard. All those will shade your building. They will not only shade your building, they will also cut the amount of natural light that comes into your building. So if you cut the amount of natural light that comes into the building, you will also have a problem with natural lighting. You might need to turn on your artificial lights. Like I couldn't help but notice Manu, when he turned on his camera, he was sitting in front of his screen. I'm guessing there was a curtain behind him, but he was sitting under artificial light. And that is a double-edged sword, right? Because if you want to work on the computer, you need to do what I've done at the back. I've got this beautiful window at the back, huge windows, which normally we keep open. It gets really good sunshine in the winters, but I have to bring them down because otherwise I won't be able to look at my own computer screen, right? Or I'll have to change the orientation of my screen. Obviously, that's the first thing that one would try to do. So we are at 40% energy saving with small windows. Small windows, again, you have to see, is there a tree shading it? Is there a neighboring building shading it? I might need to increase it to medium, and it still might save energy, even though it's a medium window. Let's go to the next one. It says window type. Now, what is the window type? Are you using double glass or are you using highly efficient triple glass? Ladies and gentlemen, I want you to know that glass is one of the most energy intensive materials on the planet. Aluminium and cement top the charts. So if you're really interested in something called embodied energy, then you should look at the IFC database report. IFC is the International Finance Corporation. I've put it in the chat box for you. If you just Google IFC Indian Building Materials Database, you will find that report, and you must see it because it gives you a methodology. How did they calculate the embodied energy and especially the carbon emissions? So Dr. Sambandam was interested in carbon emissions. So those of you who are interested in carbon emissions, that too material-based carbon emissions, IFC report is a very good database. It was developed in November 2018, and they have listed down all major construction materials that are available in India. And obviously, as soon as you go towards steel, aluminium, glass, and all these things, they have high embodied energy. So triple glazing is something that all over the world, green experts are talking about not going towards triple glazing, primarily just because of the embodied energy impact. And another thing that I want to share with you is that in India, we are a water stressed country. Even in a place like Chennai, which has excessive rainfall, they need to be careful about water. They import train loads of water every day into the city to cater to the city's demand. If we build glass buildings, you need to understand that the amount of water that is required just to keep them clean is ridiculous. And if you don't use water, you will need to use chemical solvents, which when it rains will get mixed with rainwater and go back into the streams, into our water streams for our children and their children's children. So my sincere request is always take these recommendations of green buildings with a pinch of salt. I don't know if you're aware of my history. I was one of the team members who developed Griha as a rating system. But after working 6-7 years in the system, I realized that any green rating system, of course, Griha might be one of the better ones because it's from the grassroots up and not top down. But if you look at any of these systems that are top down based, they are only reducing the damage to the environment, they are not averting it. Whereas what you might already be doing, just like we saw in the case of Remina and in the case of Manu, might be much better than any of these systems are trying to propagate. Okay, so you need to keep that in mind while you are doing this. So let's drag and drop efficient double glazing, and I'm going to subtract that just to see how much saving. So from 40 we went to 50%, which means there was a 10% saving by using efficient double glazing. But as soon as I talk about carbon emissions, especially if I'm talking about, so again, I'm just going to put this in the chat box for everybody's experience and information. It's not important for you to know from Econivas perspective, because ECBC, Econivas, they don't talk about carbon emissions. They don't talk about embodied carbon, right? So when we talk about carbon emissions, we talk about uh, site-based carbon emissions, we talk about building-based, we talk about source-based, we talk about, so I've written this in the chat box. There are about 10 or 11 different types of emissions that one can calculate, which takes more and more of the built environment into account. So for example, if I'm doing only building envelope based carbon emissions, then that's just for the building. Then if I go landscape, then it's the whole landscape. Then when I do a site level, then I take the boundary wall and I take all that also into the carbon emission factor. When I do source level, then I say, okay, how much carbon emission is happening at the source, which means the power plants where the energy is getting generated, which is getting supplied to me. So if any of you have any experience in simulation software, we also teach people how to do simulations on software. Simulation softwares will ask you, do you want source based energy consumption and carbon emissions, or do you want site based? So if you do source based, then it's going to double or triple the value, because all of us are aware thermal power plants have an efficiency of 30 to 40%. 38% is the most efficient thermal power plant in India, as per Center for Science and Environment's report, Heat on Power, which you guys can study separately. So what do we do now? Just for our knowledge, let's try and drag and drop triple glazing onto our building, and you will see that there's a 3% rise, decrease in energy consumption. So it doesn't matter whether I use triple glazing or not, but double glazing I can use, and I will get a 10% net saving. Then I go to shading. Do I have 50% shade or do I have 100% shade? Now, again, 100% shade might be a little difficult for everybody to do. 50% shading, though, anyways, we do. Now, you will notice that the 50% shading had only a 2% impact. Whereas if we did 100% shading, then we would have a 3% impact. What does that mean? That means that if I don't do shading and I do triple glazing, it's almost the same impact as shading. Whereas shading might be a more sustainable solution, because shading not only protects you from direct solar radiation but also from rain, which is why most Kerala houses will always have some form of shading device on windows. But now a lot of the new people who are doing construction, not only in Kerala but even in Mumbai, even in Delhi, including central organizations like the CPWD, we've done a lot of projects with them, will say we don't want to build shading. We don't want chhajja in the building. Why don't you want chhajja in the building? Because birds will come and sit on it. But birds were here before you came. You've taken the site from the birds. What's the harm with the birds? If the birds don't come, they don't eat the bees and the insects. If they don't eat the bees and the insects and their population goes through the roof, then the little insects that those guys control are again going to go, they're going to get finished. Now those insects go further down and eat smaller insects, and therefore you have coronavirus or you have some crazy pandemic. So everything is connected. You say, no, I don't want nature. I don't want shading device because birds will sit on it. Now, that has a long-term problem that might be much bigger than what we're imagining right now. So going for the local solutions, which people have been doing for a very long time, is sometimes the most sustainable thing to do. Now, one of the complaints that people have is that if we are doing shading devices, then those shading devices become loose, they become problematic over time. Don't do shading devices made out of concrete. Who asked you to do that? Why don't you do shading devices that people have been doing? Say, for example, in Rajasthan, they do patthar patti, stone slabs, which are fixed at an angle. In Kerala, they do brackets with Mangalore tiles on the shading devices. A lot of the old government buildings have that. Great, go ahead and do that, no problems. That's wonderful. It ages beautifully. You don't have to keep cleaning it. It looks nice. It gets washed in the rain. It complements the color of the building if it's a nice red tile. So there's so many things that can be done which people at the local level are already doing. And our biggest challenge, I feel, is to convince local people to be proud of your own local traditions and practices, and don't listen to everything that is coming to you from the West. It's very important for you to believe in yourself. Good morning, sir. Namaskar, Manish ji. So we are at 100% shading right now. And now let's look at air conditioners. So let's drag and drop a 5-star air conditioner. Or let's drag and drop a 3-star air conditioner and see what happens. So I get a 2% energy saving if I drag and drop a 3-star. And if I drag and drop a 5-star, I get I went from 53 to 57. So I get a 4% energy saving if I do a 5-star rated air conditioner. All right. So that is as far as air conditioners are concerned, and then I've got natural ventilation. So when I turn on natural ventilation, I get another 3% saving through turning on natural ventilation. So this is my normal house that I can do basic interventions. Basic interventions with. And if you see on the right side, now you will get all your outputs on the right side. It was anyways increasing it and increasing it slowly. So you have your my savings per year, 117,600 kilowatt hour was the energy saving per year, the amount of energy that you have saved. Now just imagine we did a calculation for Ramina and for Manu, and we saw that their annual energy consumption was 3000 kilowatt hour, right? And in Remina's case, it was 3600 kilowatt hour. Over here, we are talking about energy savings of 117,600 kilowatt hour, primarily because the EPI itself at the benchmark is sitting at 162, right? Then below that, it says 96,000 CO2 saving is 96,000. Now, again, I'm not very certain as to how this was done, because in India, doing a CO2 saving calculation, I don't know what methodology they've used. I don't know whether they've done site-based, source-based, so on and so forth. But this is the broad CO2 reduction in emissions that you can get in terms of CO2 savings. And then you've got money saved in INR, 4,70,400 rupees, probably one of the most important figures for people to see. So I've got a request in the chat box saying I joined late and missed the software installation part. Can you send it, please? This is the best part. This is not an installed software. I'm just going to share the shortcut with you. What we are doing right now is absolutely online and free for people to use. I have reshared the Econivas tool shortcut in the chat box. All right, so we are right now sitting at about 60 kilowatt hour. Now that you are familiar with how each component impacts your building, how much does the roof play a role? How much do the clothes play a role? How much does the air conditioner play a role? How much do the windows with the shading devices play a role? Now I wouldn't mind in you pressing the best combination button to come up with the best combination, and then looking at your energy savings. So not bad. We came to about 62, 63. No, we came to in the higher 60s as the EPI, and here we are at the higher 50s if we go for absolutely best specifications in all cases. Okay, now there is a little button on the left side bottom which says report card. If you click on report card, it will show you this kind of like a graphic output. So this is giving you the exact value. It says EPI from 163.2 to 55.4 kilowatt hour per square meter per year, energy savings of 66%, 129,600 energy saving kilowatt hour per year, and we've got CO2 of 1,06,800 in terms of greenhouse gases, equating to 2,518,344 tree seedlings grown for 10 years. I don't even know what maths they've done for that. Then it says your energy efficient home can save 5,17,200 rupees. I don't know how they've done that calculation either, because obviously KSEB rates will be different from urban areas to rural areas to semi-urban areas to industrial areas, depending on what kind of a connection you have, even within the residential setting, there'll be a lot of variation in how much you pay for electricity. So again, I don't know how this has got calculated. And then below that, it tells you what kind of a building you had. All right. So that's your report card. So this is the basic tool of Econivas Sanhita for you to understand what are the dynamics of buildings. Any doubts so far? Any questions, queries? Yeah, but how about, what if? Just feel free to unmute yourself and
Hello.
speak, or yes.
Sir, I just want to know how wall window ratio based on orientation, if I wanted to do. So right now they have already predefined. I can use small windows or glass facade, glazing. I can change. But if I want to change the wall window ratios on each side orientation, I can't
Yeah.
do that. That also affects the EPI, the energy consumption.
Yes, absolutely. Perfect. That's a great question. So that brings me to the next part, which is that we can. So I'm going to now go into a little more detail and tell you how to do detailed calculations. Uh, and so, any other questions from anyone else? That's a good question. One way of doing it to understand what is the implication of orientation on the building is to actually change the orientation in the project information. So you can actually go back to the project information, select the state again of Kerala, select the city of Trivandrum, continue, go to standalone and change the different orientation. Let's take a south facing building and then again do 300 square meters per floor and say continue. And if you see, my baseline energy consumption has not changed. But if I click on best combination, let's see how well it does. I've got a 65% saving as compared to a 66% saving. So this is when I changed the orientation and the major face of the building was facing south. So I can do the same thing. I can make it face east or make it face west. Let's quickly do that also and see what happens if I change the orientation, the dominant face of my building with the larger windows towards east. Let's do 300 again and let's do a east facing residence which is standalone and say continue. And then again do best combination. And you can see this time that if the building is facing east, the EPI becomes 180 something, right? And my energy saving is 69% by virtue of doing the best things possible. When I click on my report card, then you will see that the baseline is 182.2. Now, again, I don't know how they came up with this baseline, but
So
182.2
may I
and
interrupt?
56.1. Yeah, please. Yes.
Sir, what is the assumption that they have made? Is it that all the faces, the windows are of the same ratio, that the window to wall ratio is a constant when they do
Over
this? Because when we
here,
say north face,
yeah.
what we have,
Absolutely. This is a basic tool. So over here, everything is fixed. It has a predetermined window wall ratio, which actually is in compliance with the WFR openable ratio of Econivas Sanhita, which I will come to you now, which I'll bring to you now, right? So in all these cases, what needs to be understood is this is a very basic tool. This is not the detailed analysis tool. This can give you broad brush calculations, which will allow you to understand how much potential saving in terms of broad percentages can a person receive if they go for application of the Econivas parameters. So this is an absolute basic tool. This is not going into detailed calculations at all. Only thing is that everything is compliant as per Econivas. So where the WFAR should be within that 12.5, 13 range or less than 15%, keeping in mind VLT, it is between that range. That is what needs to be borne in mind. And now we can go into details. So over here, the assumption is just that it is compliant with the basic requirements of Econivas. Great, you're welcome. Anyone else? Any other questions, queries, doubts? Yeah, but how about, what if
Hi,
something? Yes.
Yeah, this is Callus. So I have a doubt like this software asks about the area of each floor and then asks us to customize. What if
Yeah.
I am working on a double story height for a certain area to work on best ventilation and stuff? And how does that show in the tool, or how can I customize it even more?
So that's not going to be customizable in this tool, but it is customizable in the calculations that you do, and it is also customizable in the detailed tool. So how I can do that is there is something called envelope area,
Okay,
and there is something called floor area.
okay.
Now, what happens in a building where I have a double height space? So, I hope everybody's familiar with a double height space, right? So sometimes when you enter a building, think of any, Tollywood, Bollywood movie where they've shown a residence. Mostly, if you see the hero will walk into the house and it'll have a double height, very grand kind of entrance, like the drawing room would be double height or something. Then you'll have two staircases going up, and then all the single height spaces will be on the side, right? So, very easy to do. Your envelope area will be the entire building, but the floor area will vary. So, your ground floor can be 300 square meters, but the upper floor will be lesser square meterage. And then you can also specify what direction do you have the bigger windows in, what direction do you have the smaller windows in, because in the detailed calculations, you have to specify that based on orientation. You have to take something called omega I into your calculations, which is the orientation factor of each window, right? So the amount of heat gain falling on your building is going to change based on the orientation factor. Now, again, something very simple that I want you guys to know about is that the National Building Code has spoken about orientation for a very long time. There's a detailed table that is given in the National Building Code that tells you what orientation of the building, how much solar radiation strikes at what latitude. So if you're at 8 degrees latitude or at 13 degrees latitude, how much solar radiation strikes different surfaces, and they're talking about the cardinal and the pericardinal surfaces, which means not just north, south, east, west, but north, northeast, south, southeast, so on and so forth. I've got a question again in the chat box. Have you considered or can we consider integrating Econivas in architectural design software? uh, I can't really consider that. That has to be done by the Bureau of Energy Efficiency, and I think by itself, Econivas is a pretty user-friendly tool. If you see the analytical tool, which is the detailed tool as well, it's fairly comprehensive. It's the beginning of of a software which is like a architectural software. But I think ultimately that should be the goal, that you have a plugin. So for example, you might be familiar with Autodesk 360. Now there is a problem with Autodesk 360, that Autodesk 360 doesn't thank you Autodesk 360 does not allow for it's a black box basically. So we keep having this discussion that Autodesk 360 doesn't tell you what equations it's using, how have they done the calculations, right? So if I ask for the source code or if I ask for the equations that are being used, which is why you will never find people in the domain of research using Autodesk 360. They would use a software like maybe Design Builder or eQuest or Energy Plus or Transys for simulations, because they can also study the code, and if they want to modify it, they are free to do that. So it takes a lot of time to be able to integrate even the smallest plugin into architectural software. Right now, what they have developed is a simple enough tool for anybody to use. Quite frankly, it's very easy to be able to get into nitty-gritties and tweak it. But you're right. The best thing would be if they just integrate it. And so I don't have to go through that double effort. Once I've done my design in CAD itself, the calculation happens and it gives me the output, which is exactly what Revit is now trying to do uh, through GBXML exports and this thing. And we've done one project which we are currently working on, which is for the Goods and Services Tax Department, where we've done that export. So we took a GBXML export from Revit and then fed it into energy simulation software, and then looked at the building. It wasn't a very good import. It wasn't a very clean import. and then did the simulations and saw what were the results. Of course, we had to rebuild the model from scratch in the simulation software because the import wasn't very good. So yeah, I've got another question. Is it necessary that one has to be certified energy auditor to learn ECBC course? No, not at all. Not at all. You do not have to be certified anything to do a ECBC course. Anybody can do an ECBC course. I have had the privilege and the opportunity of working with EMC for many years now. We have done ECBC courses for site engineers, for site supervisors, for JEs. It's happened for all level of people across the board. So you do not need any certification to learn the ECBC. Yes, absolutely, Mr. Vijayan. Yes, you can immediately see the effect on building cost and economics. Very true. That is the main reason why it's been developed like this. Okay.
Sir, may I intervene?
Yes, please.
Dear participants, when you post questions, please post it to everyone option. Use that to everyone option so that we all can
Yes.
see your question and understand the answer. Sir, please continue.
Great, thanks. Okay, so I'm going to stop sharing this screen and I'm going to now. So I'm going to make two requests of everyone. One is that on the Econivas website again, just make sure that you open the manual. Just have it open in front of you so that I can tell you for future purposes, anytime you want to refer to something, where is that part of, so if you go to publications in Econivas on the toolbar on the top, the publications part has two publications. One is the ECBC-R, that is Energy Conservation Building Code for residents, for residential buildings. And when you hover your mouse on it, it will say click here. So let me just share my screen and show you what I'm doing so it becomes easier. Here it is. So I was on the Econivas home page, like this is where I was, and then I went to publications right here. Yeah, thanks, Mr. Vijay. Okay, so I've got publications over here. So this is a EEBP fact sheet. You don't need that right now. Just click here on this tab which says click here, and it's going to open the Econivas manual, the reference manual, the ECBC book web.pdf. Once you've opened it, just let me know that you have the booklet open. Just say opened or yes. So it's a fairly small document, 72 pages, not very large at all, unlike the National Building Code, 2000 plus pages. So very easy to, okay, great, superb. So I've got Remina, yes, thank you. Manu, Aisha, yes. No. This energy index will not apply only when ACs are in use, but for a residence that has air conditioners that are 5-star rated and natural ventilation. So what are the assumptions that they've taken? I don't have an answer for that because this is the basic tool. So I can't tell you when are they taking into account natural ventilation, how much natural ventilation are they taking into account, because natural ventilation itself, if there are any mechanical engineers over here, they would know that natural ventilation will bring with it heat load, right? Depending on when, and it's going to bring both latent heat impact as well as sensible. And in the monsoon season, the latent heat impact will be higher on the energy consumption of the systems. So again, this is not a case, this is a residential case. It's not only when the building is air conditioned, but it's both air conditioned and naturally ventilated. Oh no, okay, I got that. Okay, thank you, Mr. Vijayan. Thank you for doing that. Sorry, he's just messaged that he's reposting the questions that he had asked me for everybody's benefit. So everybody can see. Okay. So this is Econivas Sanhita, very simple. It starts with introduction, scope, code provisions, and then code compliance. So that's just 4 chapters. So you need to remember that there are only 4 chapters in Econivas Sanhita in the book. there is the provisions of the code, and there's the code compliance, and then there are all the annexures. Yes, I can repeat opening of the manuals. Yes, just a moment. So essentially what you do is just go to econivas.com. Hopefully everybody can see my screen. And while you're looking at Econivas, you can see all the drop-down menus over here, the toolbar, access bar. I will go to, okay, Bevin, thank you so much for doing that. Yeah, I should have thought of that earlier. Bevin has just posted the link. Like, here, why do you have to go through the instruction? That's very good. Is that Dr. Sambandam? Yes, it is. Thank you. Thank you, Dr. Sambandam. I got that. So you go to publications, you just click on publications. It'll give you these two options, publications with the ECBC-R code. So you just click here and it'll open the document in a new window. And then you have the document right here in front of you. So this is the code. And like I said, there's just 4 chapters. There's nothing else to it. It's got the introduction, the scope, the code provisions, like what are the terms that you should all be familiar with. You should know these terms. Now, guess what? The best part about all these terms is you already know all these terms. You are already familiar with these terms. Only thing is you may not know the scientific language to use in these terms. All right. So how many of you have experienced wearing dark glasses to protect your eyes from the sun? Give me a yes if you've worn dark glasses to protect your eyes from the sun. Yes, so Bevin has said yes, of course. That's a stupid question. Come on, everybody has worn dark glasses. Now, how many of you have experienced that if you're wearing dark glasses and you go under a bridge, or suddenly clouds come in the sky and it becomes like rainy weather, you have to take your dark glasses off because you can't see clearly. Have you experienced that? Yes, so Nasreen has said yes, of course. We've all experienced that, right? Ramina also has said yes, we've experienced that. Now, what is that? That is a function of glass called visible light transmittance. So I'm just going to put this over here in the chat box. Visible light transmittance. And you can see right here, 3.2, I'm highlighting it on your screen for you to see, is visible light transmittance, VLT, all right? So obviously the higher the VLT, the clearer the glass, the lower the VLT, the lesser the amount of light that comes in through the glass, all right? So I'm also going to do something here. I'm going to open a new tab and I'm going to look for the Saint-Gobain catalog of energy class India. Don't worry, I'm going to do what Bevin did. I'll just share the link with you guys. Let me see where I can find. I've got the 2019 brochure. Let's see if I can. No, this is not it. Oops. If someone else can find a brochure on Google, sky glass catalog, architectural. Let's just search for efficient glass catalog. Okay, I've got the AIS Asahi India, I think, glass catalog. And I'll just tell you why I'm doing this. I'm just trying to go through a process where, okay, I've got this download brochure over here. Yeah. Now I'm going to share this link with you all, and you should open this right now in your screen so I can take you through an actual catalog that will allow you to see how to select glass which is compliant with Econivas, or for that matter, even if it was compliant with ECBC or Griha, so on and so forth. Enabling wonders, inspiring awe. Okay, let's go to. So you can go down to technical specifications. Now we are all engineers and architects, so we can actually appreciate technical specifications. Let's look at the technical specifications of the glass. This is the technical specifications of the glass, right? So I'm going to quickly first take you through the terms. I'm going to close this. I've already put the link over there. So what are the codes? What are the code provisions that the code is asking you for? Openable window to floor area ratio. What is the openable window to floor area ratio? First and foremost, you need to know what is the building envelope area, right? Now, what is the building envelope area? I'll have to bring up a PowerPoint for that, so I can also show you that. Just give me a moment. Yes, here it is. Okay, so I'm going to share my whole screen so that you can see whatever I'm transitioning to on that screen. Screen 1. Share. Let me know if you can see my screen as soon as it comes up. So this is chapter 3, code provisions. Hopefully now you should be able to see my screen. So code provisions for building envelope. Now remember, these are the same things that are written in the manual, okay? And I want you to see that so that you can see, and we can share these PPTs with you. Just remind me, these PPTs can be shared with you so that you have them in PPT format. If I just switch window and I take you to the thing that we were on before this, where is? Yeah, here we are. So this is where we were earlier. Now, if you look at this, 1, 2, 3, 4, 5, openable window to floor area ratio, visible light transmission, thermal resistance of roof, or what is the U value of the roof. Now, remember when we were doing the basic tool, we selected the less efficient and the most efficient roof, right? Then we went into something called the RETV, or the residential envelope transmittance value, for building envelopes, except roof. So once you've done the roof, then you forget about the roof. Now we have to cater to the entire envelope of the building, right? So we look at the envelope of the building. And if you were building in cold climates, then the situation will be different, which is when you go to point number 3.5, which is the U value of the envelope, only of the envelope in cold climates, all right? So let's just quickly go through this in the presentation as well. So here's how it's broken up, very nicely done. Openable window to floor area ratio is for natural light and natural ventilation, not just natural light. Please remember, the experts in the US, Indian people who are doing research in the US are now talking about openable windows and ventilated buildings, naturally ventilated buildings for pandemic control, which is called dilution ventilation. The more natural air there is inside the building, the more it is allowed to come into the building, the more it will dilute the impact of any disease carrying vectors that are in the air, right? In India, we are going in the opposite direction. Most people design and build commercial buildings which are completely sealed, 100% hermetically sealed. Natural ventilation only comes in through the air conditioning system. And in the US, they're going in the opposite direction. So it's important for us to learn that at least in our residential buildings, we should continue doing what we have always done. We should continue having openable windows and not have sealed shut windows, right? Weather stripping is a different criteria. There is a term called weather stripping. You might be familiar with it, which basically means that the window frames and the door frames and all are shut tight so that no air escapes from the side and all. These concepts are very important from a cold climate perspective, because in cold climate countries, the heat escapes. Remember, heat flows from high temperature to low temperature. Heat escapes from the building to the outdoors. In India, it's the other way around. We have to keep the heat outside and not let it come inside. But even if it comes inside, we have techniques. Like for example, in Kerala, I've seen most of the traditional houses have a little slit, which is on top of the wall, just below the roof slab. So that allows whatever height hot air builds up over there, it can escape from there. And I remember the first time I saw it in my friend's house in Kodamangalam, I was like, oh yeah, I'm going to get insects and all that will come inside. He said, no, nothing will come inside. There was no wire mesh or anything inside. And sure enough, we were in the middle of a rubber plantation, but nothing came inside. So that's the beauty of traditional wisdom. Then you've got visible light transmittance. So of course, you've got openings for natural light and ventilation. Visible light transmission is for visual comfort, for daylight, for natural light inside the building. Then you've got thermal resistance of the roof, thermal transmittance factor of the roof. How much heat does the roof resist from coming in? And once you've catered to that, then you've got the residential envelope transmittance value, or RETV. So now naturally you can see we are getting into slightly more complicated domain, but don't worry, it's very simple calculation. So again, this is a little more detailed in the sense that you've got natural light, daylight, heat gain or loss, minimum WFR op. So the openable window to floor area ratio with respect to climate zone. So it changes from climate zone to climate zone. Minimum visible light transmission. So what does that mean? What is visible light transmission? How much visible light gets transmitted through a glass? It's very simple. Now, all of you have seen cars with tinted glass where you can't see inside what's happening inside the car. The people from the inside can see due to proximity, but from the outside, the reflection is too high. Okay. So what does that mean? Let me explain that to you. Quickly go back to the catalog of Asahi glass. So I'm just going to go back to the catalog. This is the catalog of Asahi glass, what you're seeing on the screen right now. And if you look at the catalog, it shows you glass details. We'll start from the left and go to the right. Does someone have a question? Ajay Kumar, you will have to mute yourself. Accidentally unmuted yourself. Thanks, thank you. Great. So you have glass details, you've got the light factors, and you've got the energy factors, right? Now, Econivas is also asking for the same thing. You've got the glass details, you've got the light factors, you've got the energy factors. Within the light factor, if you notice, there is this box called transmission. This box, transmission, which I have highlighted right now. I'm just going to zoom in. This box, transmission. This box, this transmission is exactly what Econivas is asking for, which is VLT, visible light transmittance. Same as transmission. It is also called visible light transmission, even though transmittance and transmission are not the same thing, but they are used interchangeably. All right. So if you look under this, you will see there is glass that is at 65%, 54%, 23%. So if you look at the topmost glass, 65, let's start with the topmost glass as an example. 65% is the transmission. That's the amount of light that comes through the glass. What happens to the rest of the light? That answer is given in the columns next to that. So where it says reflection, right next to transmission, there's reflection. And below reflection, you've got external reflection and internal reflection. So if you look at a glass that has 65% transmission, 21% is externally reflected and 24% is internally reflected. Now, what does internal reflection mean? It's very simple. You have all experienced it. Every one of you have experienced it. You are sitting in your office building, the window glass is closed. When it becomes night time, you can see your own reflection in the glass, but you can't look outside the building unless somebody turns a light on. You have all experienced this. What is external reflection? External reflection you have all experienced. You're standing and you can see somebody is making their hair on the car window because they can't see inside. But inside people are sitting and laughing because they can see that that person is not being able to see inside. Right? So that is external reflection. So if you see as you go down, let's say if you go to Solaris, there's a glass called Solaris, which has 8% transmission. which means 92% doesn't get transmitted. So there again, you can see 44% is the external reflection and 36% is the internal reflection. Now, please remember, these are not summations. It's not 44 plus 36 plus 8 is equal to 100. That's not how it works. They are basically telling you under different conditions, under daylight conditions, the external reflection is going to be really high. Under nighttime conditions, the internal reflection is going to be as high as 36%. And as designers, these are important factors. So if you're an interior decorator or an interior designer and you have 36% internal reflection, that might not work from a design perspective. All right. If you go further down, you will see something called SF, or the solar factor, and then SC, which is the shading coefficient, and then U value, which is 3.6 watt per square meter per degree Kelvin. So I want to quickly just check in and ask you guys, by now, all of you, whether you are engineers or architects, will be familiar with the term U value. Does everybody know what U value is? And do you know how broadly how to calculate it? You don't need to, but if you go by the National Building Code and SP 41, you might need to. So use the chat box and let me know if you've heard the term U value. And yes, so Sajid Kumar has said yes, he has heard that term before. Or heat transfer due to temperature difference, right? Thermal transmittance value. Okay, Subramanian also has said yes. Okay, great, thank you, thank you. Remina also has said yes. Great, great. Manu has said yes. Perfect. So now, at least, I mean, obviously, this is not most people. There's just 4 people who responded, but most of you would have heard of this term U value by now. So let me quickly take it back to the slideshow, and let's see what we've got here. So first and foremost is building envelope. Now, remember, these are some terms that you need to know. What is the building envelope? The building envelope is if you read the definition, it's quite simple. The elements of a building that separate the habitable spaces, the inhabited spaces, the spaces where people are living, of dwelling units from the exterior and are exposed to the ambient, exposed directly to external air and opening into balconies. It does not include walls that open to corridors. This is very important to understand. If a wall is opening to a corridor, and that corridor is typically a doubly loaded corridor, it's got rooms on this side also and rooms on this side also. For example, maybe a budget hotel, right? It's got a corridor in the center, it's got a door that opens onto the corridor, or a hostel room, or a dormitory, which by the way is excluded from Econivas Sanhita. Econivas Sanhita doesn't consider dormitories, right? But I'm giving you an example that if a door opens onto a corridor, it is not considered as part of the building envelope. Building envelope doors have to open to the outside, which means balconies, which means doors that basically open to the outside, or windows that open to the outside. The enclosure is subdivided into obviously foundations, walls and floors, roof, fenestrations, right? And then you've got wall cladding, exterior surfaces, water resistive barriers, insulation and air barriers. So those are the various components of the building envelope. I've got a question from Shrikesh. Least U value is always preferred. Uh, well, yes and no. In many cases, least U value may not always be preferred. So I'll give you an example. We were working on, there's a school called the Doon School in Dehradun, very famous school. Rajiv Gandhi, Sanjay Gandhi, Rajesh Pilot. A lot of people are from the Doon School. So we were working on all the residences and the faculty housing of the Doon School. Now, what we realized was exactly what Shrikesh is saying, that look, ideally we should just go for the lowest U value. Doesn't that make sense? It didn't. Actually, it backfired. So fortunately, we discovered this while doing simulations itself, that if we go for the lowest U value roof and wall, the house gets too hot from the inside and that heat can't escape. So very strangely, we discovered that for a building to be comfortable in that climate, in Dehradun. This is a very old project. I mean, we worked on it about 16 years back. But back then, we had to leave the roof uninsulated. So we had to make it a cool roof, like we had to put a coating on it to make sure that the reflection and all happens, but we couldn't insulate the roof because when you insulated it, the indoor thermal comfort went for a toss. Envelope still required insulation, but again, not the least possible U value, because least possible U value might be 0.23 or zero point 0.3, which is very, very low, not very easy to achieve either. But then the envelope stops breathing entirely. So you have to take it with a pinch of salt and see what kind of an impact it is having on the thermal comfort and what is the climatic zone requirements. So there's no fixed answer for that. That walls comes under partition category. You're right. Those walls will come under the partition category. Absolutely correct. So this is a building envelope. Now, what is the envelope area? Now, as per Econivas Sanhita, the envelope area of the building is the area of the envelope minus the roof. You don't take the roof into account. You take all the walls of the building into account. The walls will have two parts: fenestration or openings and opaque part. Now, within the openings, there might be a semi-opaque part, there might be translucent part, there might be some diffused glass windows or something of that sort. That all is included in the envelope. So the envelope is going to include all formats of openings and the opaque part, which is the solid wall part. All that is included in the envelope. So when we are doing ECBC calculations, for example, we do something called gross above grade window to wall ratio. So what is the above grade wall? From the top of the ground floor to the top of the roof slab, the entire height, and then from this edge of the building to this edge of the building, that entire width is the whole wall of the building, full height, right? So then you add that, add this, you get the total building envelope area. Is this clear to everybody? It's not complicated, but I'm just asking. So far, is everybody with me? Just checking in. If you want me to repeat it, I will repeat it. So it's written over here, measurement taken horizontally from outside surface to outside surface of a building and from the top of the floor to the top of the roof slab. Not the parapet wall, top of the floor to the top of the roof slab. So that is your building envelope area. And they've got this nice little exploded view that's seen over here. Now, what are the opaque building envelope components? Opaque building envelope components are walls. Basically, you've got all your walls. Anything that you cannot see through is the opaque component. There could also be opaque panels. For example, doors might be opaque, right? Ventilators might be opaque. So that brings us to the first term of the Econivas Sanhita, which is specific, which you need to know, which is openable window to floor area ratio. Now, this is not the same as window to wall ratio. This is the term that you will find very easily in SP 41 1987. You will also find it in National Building Code 2016. Window to floor area ratio. ECBC spoke about window to wall ratio, but National Building Code and SP 41 always spoke about window to floor area ratio. Now, why did they do that? They spoke of window to floor area ratio to cater to two things: light and ventilation. So they said, if you do a window to floor area ratio of about 15% or 13% or 17%, then that is adequate for natural light and ventilation. And because it is a function of the floor area, it is catering to that floor area as well. So it is not just window to wall ratio. Now, there is an interesting graphic that I have over here, which I will see where it is. If it is not here, it might be in another presentation on how to calculate it. That is not over here. Okay, so basically, again, very, very simple. You take your floor area. Now, remember, in this case, the floor area is the carpet area. I hope you're all familiar with carpet area, right? Everybody's familiar with carpet area? Carpet area is basically the area on which you can put a carpet. So you minus the areas of the wall, right? Wherever there is a wall, you minus that area. You take your plinth and you minus the wall areas, which includes your external and your internal partition walls, and you get what is called the carpet area, the area which you can actually access. You can easily walk onto that area and walk out of it. That is your carpet area, right? So your window to floor area ratio is going to be all your windows added together, includes ventilators. All those added together, right? You've got to divide that by the total wall area. Remember I told you the total envelope area, that you take this wall, take this wall, take this wall, take this wall, add all of them together, you get the total wall area, right? These two you've got to take the window area and divide it by the wall area. You get the openable window to wall area. Now remember, when I say openable, you need to keep in mind that the part that is openable is what you need to take into account and not the fixed part. What do I mean by that? If you look at the screen right now, you've got this door and there is a certain part of it which is glass. I hope all of you can see my mouse as well. In this case, you've got a top hung window which is opening like this, and then you've got a door, right? Now the door can open 100%, which means that the entire panel can open. The top hung window may not open 100%. It might open 25%. It might open 35%. Mostly the manufacturers or the catalog will tell you. In that case, you need to take into account only the openable part and not the fixed part. So you will take the measurement of the window, but consider only 30% in your calculation or 40% in your calculation. Let me take an example from your own houses. In most of our older houses, we had what we call casement windows, which means normal windows with shutters. The entire window will open towards the outside. Maybe inside you've got a wire mesh, like a mosquito wire mesh, which opens fully on the inside, right? These days, the new houses have sliding windows, and those sliding windows will not allow the entire window opening to be openable. They'll have one fixed panel and one sliding panel, or both of them will be sliding, but at any given point of time, only 50% of the window will be allowed to be open because the panel is fixed. So I can slide it like this or I can slide it like this, but 50% is fixed, 50% is openable. So for your calculation, you need to do a window to floor area ratio openable calculation. And remember again, same thing, doors opening to corridors or shafts and all are, ground entrance doors are excluded from this calculation. So first and foremost, let me just check in and ask you guys, is this a simple calculation or is it already confusing? It's clear for you guys? It's very simple. All you need to do is make sure you take into account the openable part and then comply with the ratio provided in the Econavas Sanhita booklet. So let's just quickly see that as well. So openable, you can see in your manual, openable window to floor area ratio, page number 6. Let's quickly go to that page and see what is it that they've asked us to do. The openable window to floor area ratio is the ratio of openable area to the carpet area of dwelling units. WFR op is equal to A openable divided by A carpet. Now this is very simple for engineers. It's absolutely rudimentary arithmetic. I am an architect. My mind shuts down as soon as I see anything that looks even remotely close to an equation. No, I'm joking, but at least it used to earlier. So I'm just letting you know over here, it is nothing to worry about. It is very simple mathematics, except that sometimes it requires a lot of calculation. For example, like somebody had asked, who was it? I don't know if it was Aisha or someone, that what if I have a double height space? What if I have, for natural ventilation, I'm doing something that's different in the house? Then this is where that's going to come up. The carpet area will be different. So your upper floor carpet area will be different from your lower floor carpet area. And your window to openable floor area ratio is going to be different, right? So remember one thing, it doesn't matter whether you have open double height spaces, you want to put triple height spaces, it doesn't matter. Why does it not matter? Why am I saying that it doesn't matter whether you do open height, double height space, triple height space? Why am I saying that? And remember, my question is based on everything that we have done so far. Can someone answer that? I hope everybody's not going to sleep. Oh no, everybody's gone on a tea break. Can anyone answer that? So I'm going to repeat my question. Why did I say that it doesn't matter? You do double height, you do triple height inside your building. It doesn't matter. Why am I saying that?
Maybe because the carpet area we're calculating will be only for the ground floor if you're going for double height or triple height space.
Callis, can you repeat that? Maybe what? Maybe?
Maybe while we're calculating the WFR, the carpet area will on that particular space will only be for the ground floor, whereas the first and second floor will be the cutoff space.
Yes, you're right. From a calculation perspective, that's correct. But why am I saying that it really doesn't matter? I mean, it doesn't matter at all. Ruby, Matthew, that's it. We are considering envelope only, so it really doesn't matter. Now, I'm going to give you an example from clothes that I'm wearing right now. I'm wearing a kurta, all right. Now, let's say I do this to my kurta. I've stretched it out. What am I doing? I'm increasing the amount of area inside. It doesn't matter. The heat is going to go through the kurta. This is the envelope. I have to keep maximum attention on how I optimize my envelope. Now inside, whether there is a floor over here or there is a floor over here or there's a floor over here, it doesn't matter. The heat is going to go in from the envelope. My problem area is going to be my roof and my envelope. Because the solar heat is going to come through the envelope and the roof. So I need to take into account and be most careful about my envelope. Now, inside the envelope, it's great if I do stratification. Stratification is a strategy, right? If I do double height spaces, the hot air is going to rise and get accumulated on the top and it can be allowed to escape. And that's stratification and that's beautiful. But my aim is to prevent the heat from coming in at the source. Perfect, Ruby. Thank you for engaging and answering that question. Okay. So going ahead, now look at this, you've got minimum requirement of window to floor area ratio. Remember, this is a minimum requirement. Now that is where the challenge lies because there is no maximum. You can go as high as you want as long as you are within the EPI value of ENS. So what have they said over here? Take a look. They are saying minimum WFR operable should be 12%, 12.5% for composite climate. Shrikesh has left. He's like, this is getting too much. Warm, humid climate, which is coastal Kerala, which is Cochin and Trivandrum, 16.66% is the minimum window to floor area ratio openable. Okay. So what I'm going to do now is let's take an example. So here's an Excel sheet. And let's take an example that is simple and straightforward, very easy to do. Okay. So I'm going to let's take the width of a building, let's take the height of the building, and let's take the depth of a building. Okay. So if I look at the width or the longer part of the building, well, let me make the terminology clear. Let's take length, height, and breadth. Okay. And I'm going to do this in meters. I'm taking I hope it's clear to everybody. Let me just increase the size so people can see clearly. Let's say I take a 20-meter length. I take the height to be 3 meters, right? Or I can double it, I can take 6 meters. and I take my breadth of the building or the depth of the building to be 10 meters. Right? So the area of my building is very simple. It's a it's a two-story building, and it's 20 meters into 10 meters, so 200 square meters into 2. That's the total area of the building. Okay. So if I look at my carpet area, obviously the carpet area would be less than the plinth area. I'll have to subtract some 15-20% for the walls, right? So let's take a look at what is my carpet area. My carpet area is equal to this into this into 2, and then I'm going to take this into 0.85. So 340 square meters is my carpet area. What did I do? I multiplied 20 into 10 into 2, and I minus 15% for the partition walls and so on. Very efficient design, but I've done it anyways. So 340 square meters is my carpet area for both the floors combined. Now, if I have a cutout space or something, then my second floor is going to come further down, and I can minus that out of the 340 square meters. All right. So I have a message from Srikesh saying, I am here, sir, network issue. Is this to everyone? Can everybody hear me? I hope I'm audible to everyone. Okay, Jayaprakash, thanks. Okay. Now, what do I need to do to calculate my wall area? It's very simple. I need to do 20 meters into 6 meters into 2, right? Because there's two walls on two sides, and then 10 meters into 6 meters into 2 because there's two walls on these sides, right? So let me do that is equal to 20 into 6 meters into 2. My answer is 240 square meters, right? And the second one is going to be 10 into 6 into 2, which is 120 square meters. All right. So this is my envelope area. Remember that this is my envelope area. This is my wall area. This is not including the openings. Okay. Now, can someone tell me how much openings should I have? Now, many times people will say, oh, you should have 40% opening. No, 40% is a recommendation of the Ecbc, which is next to impossible. And let me tell you why. I hope you are all familiar with this. If you want, I'll just show you. Is there any way of creating a board? No. Okay, I'm going to ask you like this only. What is the normal floor to ceiling height of a residential unit? 3 meters. Everybody? Are you with me? 3 meters is the normal floor to ceiling height of a residential unit. Okay. What is the normal lintel height? I hope everybody knows what a lintel is. What is the normal 2.1? Manu has answered it. 2.1 meters is the normal lintel height. All right. Now, what is the conventional sill height? What is the conventional sill height of a zero point 0.6? Okay, so Manu has said 0.6. In Delhi, we normally have 0.9 as the sill height, right? So Ruby has said 0.9. Manu has said 0.6. All right. So I'm going to go with rubies to illustrate an example, and then I'll come to what Manu has said as 0.6 as well. Okay. So I've got 0.9 as my sill height and 2.1 as my lintel height. 2.1 minus 0.9 is 1.2. That is the length, the height of the window, right? What is 1.2 divided by 3? What just happened? Oh, sorry, I can't type over here. Yeah, this is the chat box. What is 1.2 divided by 3? The answer is 0.4, or in other words, 40%. This is not possible physically, because if you take a wall and you take normal sill and normal lintel, you've got a window in the center. If you stretch it all across the entire length of the wall, will you get 40% window to wall ratio. Now, normally that doesn't happen because you have structural members in between, you'll have frames in between, you have a limitation to how much length of glass you can have. You will have a mullion member in between because the glass will have panels that will slide open and close. Even if you're doing a curtain wall, there is going to be vertical members of the curtain wall in between. So you will not have 40% window to wall ratio in any case. Now, as soon as I do 0.6, I can do that also, right? So 1.2 minus, 2.1 minus 0.6 will give me 1.5. 1.5 divided by 3 is going to give me 50% window to wall ratio. But again, that 50% is going to happen if I extrude entirely from this side to this side. If I extrude, only then, if I have full running length glass, only then will I have 40%. Normally, in a residential building, that will never happen, right? So if I take, let's say, going back to our calculation, if I take a window, let's call it window 1, and I take the height of the window to be 1.2 meters, like we discussed, and I take the breadth of the window or the opening size of the window to be 1.8 meters. So what is the area? The area is 1.2 into 1.8. 2.16 meters is the area of one window. Now I've got a 20-meter facade and a 10-meter facade on the side. How many windows would you like to have? You tell me. And we'll do it as per whatever people say. How many windows should I have on the 20-meter side and how many windows should I have on the 10-meter side? Please tell me. And remember, you need to leave gaps and structural members in between. So use the chat box and engage. Remember, I've got a 1.8 meter, whereas I've got a 6-foot window. So keep it simple. We've got a 6-foot window and we have a 20-meter facade, which means it's 60 feet. How many windows do you want to have? Anyone? Hello? Are people listening? Aisha has left. She's like, no, this is too much maths for me. It's not, it's very simple. Hello? Anyone? On a 60-foot facade, how many 6 feet wide windows would you like to have? Okay, so Subramaniam has said 4 windows on the 20-foot side. 20 foot in 20-foot side, so we don't have a 20-foot side now. We've got Aisha has arrived. We've got a 10-meter side, which means I've got a 30-feet side and I've got a 60-feet side. Once, yeah, on the 60-feet side. Okay, you're saying only 4 windows on the 60-foot side. I would put at least 5 windows. Okay, let's put 4 windows. Let's see what happens. Okay, so I put 4 windows. So I do equal to this into 4 into 2, obviously, because I have 2 sides, right? So if I'm doing 4 windows on the south and the north, let's say, for example, the longer faces are facing south and north, and my shorter faces are facing east and west. So let's do 2 windows on the east and the west. So then this is my north and south. And for the east and west, I'm going to do the same thing. But this time, instead of multiplying it into 4 into 2, I'm going to do into 2 into 2. Now I made a small mistake over here because I'm doing 4 on each floor and I've got 2 floors. So I will need to do 0.9 G9 into 4 into 2 into 2. So 34.56, and here also I'll have to do into 2 into 2, which is going to give me 17.28. So this is my window area. Now this is the total window area. And obviously 100%, maybe 100% is openable. It's possible that 100% is openable, right? So my total sum is coming to 51.84. Let me sum that up. Sum is coming to equal to this plus this. This is my sum. 51.84 meter square is my openable area. Now, what did I need to calculate for Econivas? Econivas, I wanted to calculate openable window to floor area ratio, right? Which is my carpet area. So what am I going to do? WFR op is equal to this divided by this. My answer is 0.152471. Let me make life easy for myself and not complicate things. I will reduce the decimal places and I'm going to say 0.15 is my window to floor area ratio. Let's go back to the manual. Minimum requirement of window to floor area ratio for Trivandrum is 16.66, which means that I am low. 16.66%, remember? And our answer over here is 15%. Let's format this as percentage. I am at 15%. So remember, Subramaniam had said 4 windows on the 60-foot side, and I was like, no, I'll put at least 5 windows. I'm just going by instinct. 4 windows seems a little less, right? So I was right. Let's do this. Instead of 4 over here, we are going to put 5. And instead of 4 here, instead of 2 here, we can let this be 2. So just imagine I just increase the number of windows 1 on the front and the back, and I have come to window to floor area ratio operable 18%, which is compliant with the Econivas guidelines for warm and humid climate. I have crossed the 16.66% threshold. So has your brain become Faluda already, or is this clear and I can proceed? Okay, Jitin has said, okay, that's wonderful. Okay, Ruby has said, it's clear. That's great, Ruby. That's good to hear. Thanks. Proceed, Subramaniam. Thank you very much. Perfect, right? So this is your minimum requirement of window to floor area ratio. Now remember, we took a very simple example. If you are working on a high-rise building with multiple floors, with multiple windows, maybe you're even working with 3 or 4 window types, then this Excel sheet might become big. But the principle is going to remain the same. You calculate the total wall area, you sum up all the walls, then you calculate the total window area, you take out the openable part, right? And remember, inside the first step is the window to floor area ratio, right? So you calculate your total openings and you divide it by the carpet area. So you need to remember carpet area, only the area on which you can put a carpet. So that's what you need to remember, okay? Now, and oh wow, so it's written over here, adapted from Bureau of Indian Standards 2016, National Building Code of India 2016. So I told you, you will find WFAR. I didn't see this reference before, but you'll find it in NBC, you'll find it in SP41, you'll find this reference in Indian standards and codes a lot, okay? Now, even though you have gone ahead and done very well with your openable window to floor area ratio, but you are all fans of Mammootty. And unfortunately, he loves to wear very, very dark glasses. Now, those very, very dark glasses cannot allow you to see well under all conditions. So if the sky becomes overcast, or if it becomes slightly dusk like evening time, or in the winters when the sun sets faster, you have to turn on all your artificial lights and your artificial lighting energy consumption goes up. So you need to make sure that the VLT is compliant with the requirements of Econivas Sanhita. Now, what is the requirement? First and foremost, what is the window to wall ratio? Let's go back to our calculation. So this was our total 20 into 6, right? So this was our total wall area, right? This into 2, and then this into 2. So what was my total wall area? My total wall area was just equal to this plus this. This was my total wall area. 360 square meters was my total wall area. What was my window area? My window area was 60.48 square meters. So what was my window to wall ratio? My WWR was equal to window to wall ratio was coming to this much, 17%. This is my window to wall ratio. What is Econevas asking for? Let's see. Where's my document? Here it is. So A non-opaque divided by A envelope, which basically means non-opaque, a very confusing term, man. Non-opaque basically means transparent. No, either transparent or translucent. So instead of using direct term, they use indirect term. So WWR is equal to area of non-opaque, which is your transparent windows, divided by area of envelope. Now, what is it saying? It is saying whatever your window to wall ratio is, if you are in this range, 0 to 30% or 0 to 0.3, where are we? We are at 17%. So we are in this range, 0 to 0.3. Then the minimum VLT needs to be 0.27. If the window wall ratio goes more than 0.3 to 0.51, minimum VLT needs to be 0.2. So we are in this category where minimum VLT is 0.27. Okay. Okay, I got you. All right. So here's what you guys need to do. Quickly go to your catalog, your Asahi glass catalog, and tell me which glass you will use, which is double glazing and has minimum VLT of 27%. Put the answer in the chat box. Use the Asahi glass catalog. Now remember, this is solar control glass 6 mm. This is not what we are going to use. We are going to use double glazing. So this is double glazing. 6 mm solar control glass, 12 mm air gap, 6 mm clear glass. Right? You're going to go down and see which is the one that has transmission which is greater than 27 but as low as possible U value. So in the case of glass, you can do what I think Subramanian has said, take the lowest possible U value. Let's see what we find. So I've got my lowest possible U value here, 1.9, but that's ridiculous because this thing is 7%. That's too low. So has somebody found something? Oh wow, oh, this is low E glass. Okay, this is going to be expensive. So I've got a U value of 1.7. I've got a transmission of 54%, which is great. Right? And I've got a solar factor of 38, which I'll come to later. So I'm going to use clear light plus. This is what I'm going to use. If anybody else has found something else, please let me know. Anyone else? What did you find? What glass did you find? Use the catalog that I just told you and find a glass that is higher than 27% VLT and has as low a U value as possible. Has someone found something? No, nobody has found anything. Are you referring to the catalog? No answers. Okay, good. Yeah, I've got Callus telling me clear sparkle glass. Okay, Callus, let me just take a look. Where did you find clear sparkle glass? Let's see. Where did you find clear sparkle? I can see green sparkle and clear sparkle. Okay, clear sparkle. Absolutely. You're right. Absolutely correct. Thank you. Callus, that's correct. You can use clear sparkle glass, which has a 46% VLT and it has a 1.6 U value and it's got a shading factor of 25 or SHGC of the glass itself is 25, right? That's great. That means it's going to reflect all the heat. It may not even require any external shading. So let me quickly go back to the presentation and go through this. You will also need to comply with orientation factor. Depending on what is the dominant orientation of the building, there's going to be a multiplier that you will have to use in the total calculation of RETV. With good orientation and suitable shading, always remember summer sun is excluded, but winter sun is included. Now, obviously in Kerala, you don't have very harsh winters, but you have very high solar radiation in summers and in winter. So good shading is a really good strategy. All traditional houses in Kerala have a pitched roof. They will have a courtyard, maybe two courtyards. They will have a pitched roof. The pitched roof is going to go beyond the wall. There's going to be a wide veranda or a corridor that's going to run all around the house. So that's going to shade the wall from the rains also, and it's going to shade the walls from harsh direct solar radiation also. So our ancestors knew exactly what to do in that kind of climate. So this is your projection factor and overhang. Very simple. It is the H by V, which means the depth of the overhang by the vertical drop. So that's what projection factor is. If you have side fins, like if you see this image over here, if you have side fins, it's the same calculation. Just like you did projection by height of the window, you're going to do projection by the width of the window. So I'm looking at it in plan now. You're looking at it in plan from the top view. So you will do projection by the width of the window, and you can calculate the projection factor and then refer to the table that is given Econivas Sanhita. What is SHGC? The glass that Ruby just selected, you will notice in the catalog they have something called SF that is written. Now SF is the same as SHGC, which is the same as G factor, which is the same as a lot of other terms. So manufacturers will use different terms, but mostly you will find the SHGC is less than the shading coefficient, approximately 0.87 of the shading coefficient. So whatever is the lower value is something that you can take, which is the same as SHGC. Now, remember, if you are shading your glass just like you were your eyes, then you can go for glass that has higher SHGC because the shade adds to the SHGC and makes it much better. Okay. So you can also calculate, again, if I take you quickly back to the catalog, the ECBC catalog, then you can see RETV. This is the RETV calculation. Code compliance, VLT. This is your terminology. Windows thermal transmittance for you and walls. Just give me one moment. Yeah, these are your orientation factors based on dominant orientations. If you are facing due north or within a certain range of the north, plus minus 22.5 degrees, so total dimension of 45 degrees, then these are your orientation factors for less than 23.5 degrees north latitude and higher than 23.5 degrees north latitude. So this is the diagram, very easy to understand. This is the calculation, annexure 7, calculation of equivalent SHGC. I'm going to put this into the chat box. This is something that you will need to look at. Remember, I was telling you projection factor, depth by height of the window. And again, if you have a vertical fin, like for example, the housing board building in Trivandrum, or there's a nice little hotel, when you're going from the housing board building towards that Tamil restaurant, I forget the name. You've got a really nice hotel building, an old one, which again has side fins. The windows have side fins shading the building, right? So there you will use this calculation and then refer to the overhang external shading factor table, table 10 and table 11. And these are the tables that are given. Now, these tables might look complicated, but actually they are not. Oh yeah, Shrikesh has said Trivandrum Hotel. It's called Trivandrum Hotel. That's the building I was talking about. Excellent case study for external reflection, roof shading, window to wall ratio, external shading devices. I mean, everything in that building just looks really amazing. And it's such an old building, right? That's the Trivandrum Hotel. So this is your external shading factor. Again, it's a parameter that you can use to multiply the SHGC of the glass. So please listen very carefully. The SHGC of the glass is what Ruby found in the catalog. Sorry, I have to quickly just go to the catalog over here. This SF that you see over here is the SHGC. Now we've selected 25, which is very stringent. Because when you look at the external shading factor, you can actually multiply it into the SHGC to be allowed to, which allows you to take a more relaxed glass. Why would you want to take a more relaxed glass? It's cheaper. If I buy this clear sparkle, it will be very expensive. But if I buy a glass that has a higher shading factor, maybe even 40, 45, and it has a high visible light transmission, and it has a okay U value, 2.8 watts per square meter U value, no problems. Because I'm using my shading devices, I can multiply my external shading factor into this SF value and get an effective shading for SHGC value, right? So again, it's just one factor into the uh, projection factor summation that you have to do. It's again very easy to do actually. And you have to refer to these tables, take the value and multiply it into the SHGC that is given in your catalog that I just made you see. And that will give you the answer for the SHGC values. So this is the total SHGC calculation. ESF, external shading factor total, is equal to ESF overhang into ESF side fin. ESF side fin again is divided into right side fin and left side fin. So it looks like a really complicated calculation. When you do it in Excel, it's very, very easy and simple to do. And then you calculate your SHGC equivalent, right? Which means that equal to very stringent SHGC, but because you're shading it, you get a more relaxed SHGC. So I want to quickly check in with you guys. I know that this is a bombardment of a lot of information and knowledge, but it is, like I said, basic arithmetic. And I want to also ask the ECBC, the EMC cell officials, how much time are we left with? And can I go into RETV calculations or not? Because as you are all aware, RETV will again take a little time uh, for people to understand. How much time do we have? And also, please let everybody use this as an opportunity to clarify if you have any doubts. And please remember, nothing to worry. Even if we don't do the RETV, please remember that right now the page that I'm on, page 51 of 72, or 50 onwards, actually this entire section, Annexure 8, Examples of Code Compliance, is an excellent place for you to learn how to do the RETV calculations. These are all manual calculations. Maximum you need to use Excel. And the best part is that they've given this for a low cost housing project, which is a very large project. It's got 116 dwelling units, high-rise building. And for this project, they have done full-fledged RETV calculations for all of you to be able to see and learn from. It's very, very simple. So,
Sir,
yeah,
the time is already over, but can we complete this within half an hour, sir?
I would like to ask everybody if they're okay with it, then I can definitely take you through the calculations. Okay, great. So Jitin has said okay, Mithun has said okay, Jayaprakash, okay, great, super. So what I'm going to do is I'm going to do this from the manual example, so that thanks Manu, Sajid, thank you. So I'm going to do it from the manual so that you can also refer to the manual in future. Okay. Now I'm going to zoom into one of these blocks. Let's take a look at this block number A. These little red boxes that you see inside the block are shafts. They are your ventilation and services shafts. Okay. And two windows in each dwelling unit are opening into the shaft. Now, if you remember, I told you that when you do building envelope calculations, it needs to be windows that open to the outside, right? So they've given an example which has all kinds of windows and ventilators so that we can get clarity on how to do the calculation. Okay. You can see the plan north is straight up, as you can see on the screen right now. Plan north is straight up. Naturally, that means that there are a few blocks like block J and K that are facing east. So their longer facades face east and west, and the rest of the blocks are more or less facing north and south, and there are some changes in angles like this, right? Now, why is the angle important? Because our orientation factor is going to be taken into account for the angles. What they've also done is they have given a typical dwelling unit floor. This is a typical dwelling unit floor. So you can see there's three types of windows, W1, W2 and W3. These are the windows that open to the outside. Then they've got a door called D, which you see is opening to the outside. There is an entrance door that is at the bottom of the plan, but the entrance door doesn't count because the entrance door opens onto an internal corridor. There's a doubly loaded corridor, flats on that side, flats on this side, like a dwelling unit on that side, dwelling unit on this side. So this door doesn't have anything written on it. And then you've got two V's on the bottom right corner. You see there's V and V, which are your ventilators. Both the dimensions of the ventilators are the same. So there's a drawing room, there's a kitchen, open kitchen, there's a like a utility balcony, and there's a bedroom, and there's WC and there's bath. So table 16, details of exposed doors, windows and ventilators, example 1. So the first thing that they've done is they have made a list, W1, W2, W3, D and V, two numbers, right? So they've mentioned what are the opening height, opening width, opening height, opening area, right? So opening area is what? Opening area is very simply, I think they've just multiplied the two and taken into account whatever the opening area or the openable area of the glass is. And then they've also got the opaque area. So height of the glass in opening meters, glass area in opening meters, and then the opaque area. So remember, you have to calculate both the opaque area and the open area. The opaque area will include a frame, it may include a PVC panel that is embedded in two parts of the frame. All that you will need to take into account. What are the construction materials? You need to know what are the construction materials. They have given the construction materials. If you remember, the case study that we had done on the online tool had three options for the wall. First one was AAC with external plaster, with plaster on both sides. Then there was brick with 50 mm insulation. And then there was brick with 100 mm insulation. So here again, they have given the materials that are being used. Wall is 200 mm AAC block, which is the same as example 1. People, please remember, it is same as example 1 of the basic tool that we did online in the morning. With plaster on both sides, U value 0.78 watt per square meter. So please remember that a U value of a normal brick wall can be as high as 2.8, 2.9 watts, even 3.3 watt per square meter. Here, because of the AAC block, you've got the U value as 0.78. Roof 150 mm RCC slab with 40 mm polyurethane foam puff insulation. Glass is single glass. Obviously, this is an affordable housing project. I'm not going to use double glass in this. So I'm using single clear glass SHGC 0.8. Remember what Ruby found in the catalog was 0.25, which was really good. Here I'm talking about 0.8 as the SHGC factor. VLT 85% and U value is 5.8 watts, which is like the worst possible high U value glass available. PVC panels. The doors are PVC panels. So you've got 4 mm thick PVC panel used in doors and windows. U value 5.23 watt per square meter. Question is, does this project comply with the code? So how do you do the compliance check? You first look at what is the orientation of all the blocks. In this example, compliance of tower C as marked in figure 9 is being given. So this is tower C, as you can see. I'm going to zoom into the tower. This is tower C and we are trying to do a compliance check for tower C. Please remember that you will need to do a compliance check for all the towers. The longer side of this tower face north and south. So let's keep it very simple. Here we are looking at orientation of pure north and south. We are not going into too much tilt and all that will complicate the calculation. It has 112 dwelling units, 16 dwelling units on each floor. Going back to the plan, you can see 1, 2, 3, 4, 5, 6, 7, 8 and then on the other side of the corridor. So you've got 16 dwelling units per floor and 112 dwelling units in the total block. Half of the dwelling units face north, half of the dwelling units face south. So this is your orientation, total wall length exposed to ambient. Total wall length 51.58 meters. Total wall height in meters exposed to ambient is 21.06. This is the total length. Remember, from outside surface to outside surface, total length of the wall is 51.58 meters. Total height of all the floors together is 21.06 meters. Same calculation that we did in Excel, we did it at a smaller scale. And you multiply the two and you get your final answer, which is 1086.27. Simple arithmetic. Remember, outside surface to outside surface, from top of the floor to the top of the roof. That height into this width will give you the total wall surface on the north. So north and south are the same, exactly like we did in the Excel sheet before. North and south is the same, and then east and west again is the same. 31 is the depth, height remains the same. You multiply it and you get the total envelope area of 3478.26. So we are currently working on a housing project where we calculated the RETV value, and the envelope area was coming out to be 26,000 square meters. So here this is an easy kind of calculation. You're talking about 3,478.26 square meters. Is everybody clear so far? How did we do this? Outside surface to outside surface, top of the roof floor to the top of the roof. Just multiply these two values into 2, and you get the total envelope area. Is everybody clear with envelope area and how we did it earlier? Perfect. Yes. Okay, good. Excellent. Then we come to openable window to floor area ratio. We've already done this calculation at a much smaller scale. We're going to redo it over here. So again, W1, W2, W3. What is the opening area and what is the openable area? So Econivas Sanhita says, if I'm not mistaken, yeah, it's written over here, 90%. You can assume that 90% of the area is openable, especially in a casement window, which means that the window is inside the frame and it opens fully and it closes fully. This is not a top hung window, it's not a sliding window, it's none of that. All right, simple window. You can assume 90% of the opening is considered openable. Rest of it will be frame, will be mullion members, so on and so forth. Okay. So here, what have they done? They've taken 90% openable, and for 112 flats, they've directly multiplied it and they've got 668.81 as the openable window area. Okay. So direct answer, W1, W2, W3, D was the opening door, and there were those two ventilators which were opening out into the shafts. Your total openable area for each flat is 5.97, and if you multiply it into 112 dwelling units, you get the total answer of 668.81. It's done. It's as simple as that. Now, once you've done this, they've taken the carpet area, 112 dwelling units into 26.6 is already given in the beginning. That the total carpet area is 2979.20. So what is the WFAR or the WFR operable is 668.2979.2, which is 22.45%. Now remember, Econivas showed us a table which I showed you earlier, which gives you minimum openable WFR, not maximum. So 22.5 is well above the composite climate. Remember, Kerala, we saw that it was 16.66% minimum WFR, right? In hot, dry climate, composite climate, it is 12.5%. And right now we are sitting at 22.5, which is much higher than 12.5%. So that's how you will calculate your WFR operable. Is this calculation clear so far? Is it simple enough and straightforward enough? It's very simple, it's very well explained, and I'm doing this from the case study so that you yourself tomorrow can anytime open the case study and use it as a reference. Next thing that we wanted to look at was window to wall ratio. We've already done this in the Excel sheet. You calculate the window area, you calculate the total wall area, you divide the window area by the wall area, you will get your window to wall ratio. The windows are either fully glazed or partially glazed, glass and PVC panels. The door is opaque with PVC panels. So calculation of window to wall ratio example 1, you take all your windows on the north, south, north and south. So notice over here, east and west doesn't have any windows. East and west has no windows. The windows are only on the north and the south. So they've eliminated all format of high heat gain. East and west will have very high heat gain. If you remember the tool that we did in the morning, the basic tool, when we changed the orientation of the main facade towards the east, our EPI value shot up to 182 or something like that. Whereas before that it was sitting at 164 in some cases, 170 in some cases. So highest energy consumption was if the house faced directly east or directly west. So in this case, east and west is eliminated. Opening name, opening area, non-opaque, that is your transparent or glass area, number of openings, total opening area and total non-opaque or glass area. So that gives you your total value of 253.16 square meters, which again you will divide with the total envelope area, and that will give you 0.073 as the window to wall ratio. Now remember this, a lot of us feel that window wall ratio should be 40%, 30%. I illustrated that to you earlier itself, that it cannot be 40%. It has to be less than that for any sensible design, especially in a residential building. Now imagine in this case the window wall ratio is coming to 0.073. 0.073, which is of course in the range of 0 to 30%, but it's almost right next to 0. So what do you do in this case? You have to have a minimum VLT of 27%. I actually find this it's quite ridiculous. If you want good quality light in your house, then you should be going towards glass which is 60, 70, even 80% clear. VLT 27%. Anyways, we are meeting because they already told us that the VLT of the glass is 85%. They've given in the specifications already, and the VLT for a place like Rajkot is minimum 27%. I'm meeting it, so it is ENS compliant. There's no problem. What is the next thing? Next thing I need to look at is how to control the roof. Now we've already spoken about this. What is the thermal transmittance of the roof or the U value of the roof? In this case, they have given the roof construction. So remember I told you, you have the plaster, then you'll have the roof slab, then you'll have maybe a slope giving some sort of a layer, then you'll have something else, then you'll have something else. So over here, they have given it from top to bottom. So look at this carefully. China mosaic tile right on top. Below that, concrete laid to slope. Below that, polyurethane foam. Below that, cement screed. Below that, RCC slab. Below that, internal plaster. So I was taking you from here to here, they've taken you from top to bottom. If we go again from inside to outside, you will see internal plaster is first. This is your ceiling plaster. Then comes your RCC slab. Then comes your cement screed or slurry. Then comes your polyurethane foam. Above that is concrete laid to slope. And then your China mosaic tiles are embedded directly onto the concrete. I don't agree with this detail. This is not likely to work because you need something. The concrete has been laid to slope. Okay, I guess it might work, but I don't know how they must have given it a slope. So the total thermal resistance, this is one way of calculating it. Normally you don't need to go into this kind of calculation. There are software or even Excel sheets that are available on the internet. In fact, if I just show it to you right now, just go to Google and you say U value calculator and you say Excel and you press enter. You will get lots of U value calculators. Here's free download U value calculator based on ASHRAE. Download U value calculator based on ASHRAE, U value calculator Anthem, usual. So I'm just going to copy paste this link for you guys in the chat box and you can just click on it and you'll get lots of U value calculators. So you don't have to calculate this physically yourself. You should know the principle behind it, but that's about it. So the total thermal transmittance of the roof is 0.47 watt per square meter Kelvin per degree Kelvin. This is less than the maximum U roof value of 1.2. So what is ENS asking you to do? If you are in composite climate, your roof U value should not cross 1.2. In this case, it is 0.47, much less than 1.2. Pass. The project has passed. And your final step, step 4, is calculation of the RETV value. Now, Calculation of envelope area for each orientation we've already done. If you remember, outside, the whole thing, right? So north, south, east, west, the total area that we had already got as the total calculation was 3478.26. We have already received this value above. The U value of AAC block and PVC sheet are calculated the same way as they are shown for the roof. The thermal conductivity of AAC is 0.184 watt per meter Kelvin and that of PVC is 0.19. Now, where did this conductivity value come from? If you open the National Building Code or if you open SP 41 1987, they will give you U values, but they also have material property tables. If you want to calculate U value yourself, you need specific heat capacity, density, and conductivity. These three values you need. And in engineering, all of you would have done it. Maybe some of you had done it in architecture as well. But if you have these three values, actually forget about architecture and this thing. We've done this in 9th class physics in school. Specific heat capacity, density, and conductivity. If you have these three values, you can calculate the U values. So they have mentioned over here conductivity value of AAC block, which is readily available in your Indian national codes. So this is your SHGC of non-opaque openings. We've already done this, so I'm going to skip this. This is your total calculation of RETV. Now, it might look like a very, very heavy mathematical calculation. It's not. I'm going to take you through it. 6.06 is a coefficient that you need to take based on climate zone, as is 1.85 and as is 68.99. Those are coefficients that will vary with what is the envelope component. What does that mean? Please take a look at this carefully. I'm going to zoom in. If you notice, this says A opaque into U opaque into omega I. Very complicated looking calculation. It's not. A opaque is what? Area of the opaque surfaces. U opaque is what? U value of the opaque surfaces. Omega I is what? The orientation factor of these surfaces. Only thing is you need to sum these up. So you'll have one wall, second wall, third wall, fourth wall. You will have to add all these together. Then you come to non-opaque. Non-opaque is what? Transparent. Glass. Total area of the glass into the U value of the glass into the orientation factor of the glass. That's it. Nothing else. And finally, remember that glass allows heat through it in two ways. Glass allows heat through it the way a wall allows heat through it, U value, that is due to temperature difference. It also allows heat through it due to direct solar radiation. So I'm going to ask you okay, I've got another comment. I'm going to take that comment up. It's an interesting one. All of you might have traveled either by car or by airplane. So I'm going to give you a very, very simple example. SHGC is a very, very important component, which is why in the calculation you see 68.99 into area of the non-opaque, which is the glass, into the SHGC of the glass, into the orientation factor. All of you would have traveled by airplane. Now you need to remember, in an airplane, if by chance you're sitting on the side where there is the sun, you need to bring your blinds down. You need to block the sun from coming. Right? All of you would have experienced this. Now, what is very simple to understand is that glass outside temperature is minus 45 degrees Celsius. If you're on a domestic flight, if you're flying to Dubai, the outside temperature is minus 55 degrees Celsius. The inside cabin temperature would be 25 degrees Celsius. So the temperature difference from the inside to the outside is as high as 70 degrees Celsius. Ideally, heat should be flowing from inside to outside, which means that heat should be flowing from the inside of the cabin to the outside. But that is not what happens. What happens is that the cabin becomes so hot due to direct solar radiation that you have to bring your blinds down. That is why SHGC is much more important than U value in the case of glass. Much, much more important. Now, if I ask you what is the window wall ratio of an airplane? Ridiculous. Window wall ratio of an airplane would be 1%, maybe even less than 1%, maybe 2% maximum. but there is so much heat coming in from the glass that you have to bring your blinds down. So the third component of the RETV calculation is very important, 68.99 into summation of A non-opaque into SHGC into the orientation factor, which is term 3. So you put these into your Excel sheet. You've already calculated your areas. You already have your U values. You only need to take the orientation factors and you get A into B into C and you get the term 1 total. Simple arithmetic. Again, you do the same thing for the glass with respect to U value, and you do the same thing with respect to glass with respect to SHGC. So you get your total values. And then you do RETV 1 divided by 3478, which we used in the earlier calculation as well, into the prefix, that's your coefficient climate wise, into the 3 values that you got, each into the coefficient climate wise. So the total RETV value comes to 9.46 watt per square meter. That is the total amount of heat that is coming into your envelope through the envelope, regardless of whether the envelope is glass or wall. It doesn't matter. This is the average heat that is getting transferred through your envelope. So the answer is 9.46 watt per square meter. Now the main thing that we need to look at is that this is less than the maximum RETV value of 15 watt per square meter. Hence it complies with Econivas Sanhita. So this is effectively exactly what any engineer over here who is an HVAC engineer, if you do heat load calculations, you use a CLTD sheet, a cooling load temperature difference sheet, or a cooling load factor, a CLF sheet, will be very familiar with all this. In fact, this will be very easy for them. For the architects, it might require a slight change of track in thinking, but again, it's very easy to do. Once you get it, once you start doing it, you'll realize it's just multiplication and addition, nothing else. Only thing is you have to be careful about the number of windows on each orientation, number of different ventilators, so on and so forth. Yes, Aisha.
Sir, any component of thermal comfort coming into this?
None whatsoever. No component of thermal comfort is mentioned in ENS at all. So thermal comfort, of course, is mentioned in NBC. It's mentioned in NBC Part 8, Section 1 and Section 3. Section 1 is the tropical summer index and the operative temperature values. And Section 3 is the adaptive Indian thermal comfort band as developed by Professor Rajan Rawal at CEPT University, right? So for thermal comfort, I would recommend you refer to the National Building Code Part 8.
Okay, sir. Thank you.
Most welcome. See, you have to understand the perspective, the context of ECBC and of Econivas is to minimize energy consumption in buildings. And I feel that obviously it's not adequate. Energy is being consumed for thermal comfort. Thermal comfort should be taken into account. But at least as of now in Econivas, as far as I'm aware, there's no aspect of thermal comfort being taken into account. So the second example is given over here, example 2. This is for cold climate. So cold climate, your roof U value is a little different. In fact, the overall envelope U value is different. So in case some of you are working or have projects in cold climates, you can refer to this example. Otherwise, this example that we just did is good enough for reference purposes for you. So any questions, queries, doubts? I know I had to kind of blaze through this example, but hopefully it communicated the broad easiness of the calculation. It's very simple to do. And the best thing to do is what we did today, which is to start with a very small example. And I would highly recommend, because we've done this with students as well. My colleague Pravar is sitting here. He's done it with all the students at SPA this semester. Just start with your own house. Do a basic RETV calculation, WWR, WFAR, and you will realize, you might just discover that you are already compliant with the Econivas Sanhita in your own house. That's the best way of learning it. And then you can scale it up. So there's one question that's in the window. I've finished much faster than half an hour, so I'm going to just take up that question that's written there by Vijayan sir. Another generic observation you may ignore if you like. I think about holistic solutions from a broader view as per Vastu. If you believe, recommends east facing. As per Econivas, east facing is not recommended. How do we combine all these? So I want to clarify something over here. Vastu does not recommend east. I am working currently, not really working, but I have some close association with the Vastu Vibhag of the National Sanskrit University in Delhi. They are PhDs in Vastu Shastra. If you look at any temple in South India, any temple, you will see that the openings towards the temple, that is, the temple faces east. The Garbhagriha will face east. You will come from that side to worship. But the overhang that is going to shade the lingam is going to be very, very deep. So Vastu recommends east facing mostly for temples. But if you are going in for residential Vastu, then you might be aware that they first need to study your astrological chart, then recommend what is the best orientation for you. There is no blanket rule, just like in Ayurveda, there is no blanket rule. Every human being is the same, everybody can have a discipline and become okay. That's not the case in Ayurveda, it is not the case in Vastu Shastra either. For the people who are steeped into Vastu, they will tell you that there are many, many ways of dealing with it. And I personally think that Vastu goes much, much beyond what Econivas or Griha or IGBC are talking about, because they also go into mental health. They also go into aspects of what orientation is bad for certain type of people, what kind of an emotional impact does it have, what kind of a long-term impact does it have. Like I've actually seen attended sessions of Professor Pravesh Vyas from National Sanskrit University, who says that it can also predict in some cases where if the house main entrance is from a certain orientation, it might have a negative impact on the children that are born in that house, but not a negative impact on the occupant of the house or the lord of the house, so to speak. So I don't think we should try and combine these two things, even though I think there is no clash between the two, because the work that I was doing with them was to try and explain to them that whatever we are doing today, there is no clash between the two. If we talk about Yum being in the southwest with the fattest walls and the master bedroom being in the southwest, it is very consistent to, if you look at the incident solar radiation and the optimum orientation diagrams that are given in the National Building Code. Only thing that the National Building Code and ENS and ECBC don't cover are the aspects of Vastu Shastra, such as what I mentioned, which are I think amazing. They just go way beyond, and they're mathematical. They're not just pseudoscience. There is a basis in astronomy and astrology for them. But that's a great question. Thank you so much for asking that question. I know a lot of people ask these questions, and because so many people ask me these questions, I kind of had the opportunity of interacting with these experts, and it is eye-opening. In fact, I have actually done a short-term course as well for English-speaking audiences with Professor Vyas to kind of translate it and communicate it to them. But I know that Kerala is a hub of some schools of Vastu Shastra that have been on from the time that we were in college. So you must explore that aspect as well, because I think it balances it out very, very well. One more thing I wanted to mention also was that we must remember that Vastu Shastra comes from a time when most of our time was spent outdoors. People used to have professions that were largely outdoor based, or they would have separate rooms in the houses where they performed their profession. These days, we, especially post pandemic or even otherwise, we spend a lot of time indoors. We want natural light also indoors. We want all the comfort indoors. We want everything indoors. So that the windows have changed and the technology has changed, and now we want like air conditioning also indoors. So if we go back to our traditional lifestyles, which is why when I started in the beginning I was talking about farmers, I was talking about people who are more engaged with nature, they naturally will have very, very low energy consumption in their houses, because there's nobody sitting in the home guzzling energy. They're actually spending their time outdoors. So many people would be doing that. So yeah, that's quite a mouthful. Okay, there's a Google Doc that has been shared with me on a private window. Okay, that's a feedback form. All right, perfect. So that's all I wanted to share with you guys. I hope that this was useful, and I hope it wasn't too much of didn't make some sort of halwa in your brain. But if you just practice the examples, and again, like I said, start with your own home, you'll be masters of Econivas very, very easily in a very, very short span of time. Oh, yeah, that's a good question. BMS and Econivas. So can be done, not difficult at all. BMS systems can be programmed very easily to respond. So remember that there are two things to this. Number one, BMS is a operational phase technology. Econivas is a pre-construction phase calculation system. So first, this needs to be understood, right? Second, Econivas is focused on envelope optimization and not so much system optimization. BMS is going to be controlling the systems in the building. So I would say that BMS can very easily be programmed to comply with ECBC, GRIHA, IGBC, more complex systems that lay down very specific performance parameters for mechanical, electrical, and pumps and so on and so forth. Whereas ENS is very easy. So I think BMS is like Big Daddy and ENS is like a baby. So no problem. Very, very not no clash whatsoever. That's what I would say. There's a request that Ijaz has made on the chat box. Please fill the feedback form, and we also fill it myself. Oh, I wasn't a participant. How relevant were the subjected sessions? Very
It's
high
for the
relevance.
participants.
No problem. I'll also fill it. See, were the interactions and doubts during the session handled effectively? Very well handled. I don't know who the instructor was. He did a damn good job. How satisfied were you with the contents? Excellent. Super. Rate the master trainer 5 on 5. Rate the master trainer based on communication 5 on 5. Rate the presentation of master trainer. Meta presentation, the relevance would be a 4. Presentation was not very good. How effective were the interactions from the EEB cell? Excellent. Was the training session relevant to your job? This is my job to some extent at least. Do you recommend this training session to other professionals? Yes. How interested are you for future programs? Very interested. Perfect. Submit. I have submitted it.
So can we have another
Okay.
session for the advanced tool and the optimization tool as well?
Yes, I think if EMC is organizing it, we can do that. The optimization tool can be done. It's quite interesting, though obviously I find it a little dull because we are into simulations and slightly more advanced software. So, but it's nice. It's simple and it's effective. We can do that. That would be up to the Energy Management Center to organize. Yes. Super.
Sir, I just have a doubt. There is a ECBC, we has arranged a star labeling for housing, and the tool
Yes.
is not working. It's an online tool and it's not working. Is there any way I can use this compliance methods and make it for a star labeling anyway?
So if you go
Can
to
we
the
connect it?
Econivas website, you will
Yes.
find information on the star labeling there itself. So I'm quite certain that there is some compatibility between the two, because if you look at the residential energy label for star labeling of residences, it also talks about EPI.
Yes.
So if
And
you're applying Econivas and you bring the EPI down to a really low value, like what we did with Ramina and with the Manu's house, then I think you can get the star
yeah,
labeling
but
quite
that
easily.
was like an online tool with the, I think that was a limited materials are there. We have just two values for Windows, small or big, and that
Yeah,
is a just limited thing. And we are getting the EPI value, that is correct. But if we
yeah,
go for an Econivas compliance method, or we are doing the compliance, we are not talking about EPI. There is no way I can get an EPI value for a residential.
correct.
My major issue is where can I get a base case or base standards for an EPI for residential places?
That's a good question. I think a base case value, Prabhat, would you know the answer to that question? Where would I get a base case for a residential unit? How did we do the IGBC Platinum's residence homes, green homes? Was there a base case for EPI? Oh, yes, obviously. Oh, shucks, that's right. Oh, yeah. I sometimes forget the basics, and my colleague reminds me. So, what we do in the rating systems is that we create a base case based on ECBC. We will take the parameters of the ECBC, which is very stringent, and then we will develop a base case in the simulation software based on that, and then try and beat that base case by optimizing the design. And that base case is acceptable across India. So,
ECBC value for the commercial buildings.
ECBC
for
value
the
for,
commercial?
so yes, you will be quite surprised. We have used ECBC for commercial buildings in
Okay.
residential buildings from the year 2006, including the Dune School project. It works, and it works
That
quite
was
well.
my okay. I got it.
It works quite
Thank
well,
you.
yeah. So we
Oh,
use the same values.
so I can show the values where I've been collecting is the ECBC commercial building for the residential also. Since I
You
don't
can.
get any PI values for, but there is a climate we have because of the climate zones, I can get U values for such and such projects. Okay.
Absolutely, you can. And best thing to do is to look at the Griha manual, because that has U value EPI values for different categories. So they've got EPI values for residences. They've got EPI,
Affordable.
and what we do in Griha also is that we keep making the EPI values more stringent. So if you see, when we started Griha, the 5 days a week 9 to 5 building had a EPI of 140, which is already, for a commercial building, which is already less than ENS.
Yes.
Now it is 90. The EPI value is 90. So every year we look at the best buildings, and then we create a lower benchmark based on the best buildings, and then people come and beat that. So then we lower it further. So you could
Okay.
use that as the baseline EPI.
Okay.
Also, please don't hesitate, Ruby. I don't know if you were there in the beginning when we did the exercises with Ramina and with Joseph
Yes, I was
and
there.
Manu, right? So the real challenge I feel is in beating the EPIs that our houses already have. That's the real challenge, because
Existing.
if Manu's house is at a EPI of 7 already, then
So that
what?
is one of the thing I want to say. In
Yeah,
Kerala,
yeah.
it's like a plot area. If you are going for a plot area, like we are acres of plot, and the
Hmm.
residence is very small, even
Hmm.
you get a 20%, 20% ground coverage. I won't say we ground coverage calculation will be there. So the EPI is
Hmm.
getting more like 0 point something. The people were saying it's the same thing. If I go for a EPI calculation or something, and we are having a point value, that it's like a more
Hmm.
like a 4-star label, 5-star label. It won't be, but it is maybe the issue with the calculations because we don't have a proper
No,
standards
no,
for this.
no, I don't think so. I don't think it's an issue with the calculation at all, because the site area doesn't get counted into the carpet area. When I'm doing a calculation for my any of them, WFAR, WWR, RETV, I'm not taking site area anywhere. I'm only taking the building
The
performance.
Econivas is saying like the plot area of more than 500 square meter.
Square meters, yeah. A
Plot
plot
area.
area of more than 500 square meters, yeah. And come to think of it, you're right actually. 500 square meters is a fairly large plot. Like even in Delhi, a 500 square meter plot is pretty big. It will be considered a luxury plot. And then if you break it up into floors and you do 4 floors, let's say you have a ground coverage. I think with a 500 square meter plot, you are allowed a ground coverage of about 60% or something.
Mm.
So per floor, you're going to be sitting at 300 square meters per floor. And then you'll
Mm.
minus circulation and common areas and all, you'll be sitting at around 275 square meters. And then you do your EPI value. So I think even if you looked at the residences that are above 500 in Kerala, I wouldn't be surprised if you find EPI values much less than what the ENS is talking about. Like the exercise that I did when we were studying the electricity bills of the students at SPA,
Mm.
we found that even the most luxurious people, like the people who had 6 air conditioners in their houses running through the summers, they had EPI values in the range of 25, 30, 35. but not as high as the benchmark EPI of Econivas. So
Okay.
I think it's a matter of reconsidering where are these benchmarks coming from? Who is giving these
Yes,
benchmarks? What
yes,
are they
that's
based
right.
on? You know, are they really based on Indian codes? Because I was shocked. Like there are these students from Rajkot, not Rajkot, sorry, Kota. There was a student whose village is close to Kota, and his energy performance was coming to 1.4. Very simple. And I asked him, like, what do you have in your house? He said, nothing. Our whole house is cooled by one cooler, and that does the job. And I can't doubt that because my own house in South Extension was cooled by one cooler, and it cooled the whole house. So what does one do in this kind of a case, you know? So yeah, that's interesting. I
And
think
here
that's
also
what
we are
regional.
mostly
That's the
having ventilated.
regionalization.
Yes,
Say
and
that again.
because of
Sorry.
the
Say that
same
again.
reason, I'm saying we here also this is morely natural ventilated buildings are there. Not
Exactly.
every residence will be having an
You're absolutely. You're not relying so much on air conditioning systems.
yes.
Yeah,
Okay, sir.
if you build a building like Lulu Mall, then yes, you have to. You don't have a choice except to go for like really heavy centralized air conditioning systems. But otherwise, I've even seen hotels in Kerala will rely on splits and have openable
Yes.
windows and very comfortable, very comfortable. So yeah, I think that's where the localization needs to come into the picture. So you as engineers and architects need to kind of focus on localization and say no, the benchmark needs to be different for Kerala because it's a different local context.
Thank you, sir. Thank you for clarification.
Please give your email. You're most welcome. Email ID and phone number. So this is my phone number. And oh, sorry, I sent it to Mr. Vijayan. One second. And this is my email ID as of now. It is sorry, I have multiple email IDs, so you can preferably just contact me not on the Gmail ID. I don't see it that often. Okay, great. Thank you very much. Thank you very much, and have a pleasant day. And I hope this is valuable to you and you take this forward. Anything else needed from my side, Ijaz, or I can sign off?
Okay, sir. Thank you for this well organized interactive session. Thank you, sir.
Thank you.
Dear participants, please fill the feedback form.